Hey, good evening, everybody. Welcome to tonight's webcast. As always, I am Pete Meyer, good friend.
Truly, I'm still me. The last time I checked.
We know, again, I wanted to start off the webinar tonight by saying that we know that there's a lot of things that you could be doing on a Saturday evening. We appreciate you making the choice to spend that time with us. And if you've come to any of our webcasts or any of the presentations that either of us have done live, you know that we do share one thing in common. We respect and understand that your time is valuable, and we're going to do everything in our power to make sure that your decision to spend your time with us was a wise one and that we don't waste a single second of it. Like we kind of teased in the beginning, tonight's topic, a professional approach to battery starting charging systems. No, it sounds kind of fundamental, but we also promise that somewhere along the line, we're going to show you at least one thing that you didn't know before, and hopefully bring you up to speed on the challenges that you face today's electronic and electrical systems.
Right? Yeah, and Pete, we were discussing something before off camera. This is basic stuff, but guess what? What fixes vehicles?
Yeah.
Basic stuff.
Yep.
And knowing that, just like we have a BMW here in the other bay, and that X5, okay? I was going to say a 3 at first until I turned my head.
Background there.
That X5 only got Pierre, Mr. BMW expert, but that X5, they've had problems with batteries where they have changed the CCA rating and you had to update it, okay? So a battery is not a battery. It's just like a regular 12-volt lead-acid battery. It's 2.1 volts per cell, right? 12.6. Well, when you get an AGM battery, that's no longer true. You're about 12.8. So these are little things that you have to know. Why? Well, if you put the wrong battery in that BMW, or for that matter, any vehicle, we could have a bunch of different problems.
Absolutely. And before I go too far, I certainly don't want to forget to thank TST VP Pierre Respo for helping us man the board and the chat box and throwing in his commentary from time to time from his world of expertise in the BMW field. And then I have to credit their Ms. Doreen.
Yeah.
Our lovely camera person there that takes care of making sure that you can see what we want you to see, and then sometimes things that we don't want you to see, but that's okay. That's okay.
Hey, what do you want for free?
Yeah. And the other thing I want to point out here that I've been saying a lot lately, when you're watching this tonight, yes, battery started charging systems sound, and it is fundamental stuff, but you know what? The fundamentals are changing on a daily basis. And you're going to see some things tonight that maybe you weren't quite aware of and you don't think about, because this is something that you do routinely every single day, and you just keep doing it the way you've always done it, right? So you don't know necessarily what you don't know. Hopefully we'll shine some light on that. And the other thing I want to start off to before we dive into the meat of the matter is this. The vehicles that you guys and gals are working on today are the most highly technical, highly complex marvels of engineering that the automakers have ever produced. And we've been facing challenges throughout our careers and new technologies, but not at the pace that they're coming at you today. The whole thing about this, when you're working on those vehicles in your shop today, close enough ain't good enough anymore. You are either fixing the vehicle right or you're fixing the vehicle wrong. And probably preaching to the choir, because you're here tonight to learn to make sure that you are fixing the vehicles right. And we want you to know that we appreciate that and want to do everything we can to support you on that. Okay.
No doubt.
All right. Got to give some credit, of course, to the folks that made tonight possible. That's our friends at Duralast.
Yes. And maybe third time back this year?
Yeah. In fact, they're already wanting to help us out again next year. And for all the sponsors that you've seen over the course of our last several webinars, guys, give them some props, check them out, see if they can help you in the course of your business and your daily job, because they have an interest in doing what we just said, helping you in those lines.
And they even welcome your feedback. So if you have a problem with, in this case, a Duralast part or something, don't just bitch and moan. Let them know what is actually wrong with it.
Yeah, I'm going to encourage you, go to the website, duralastparts.com, and check them out. You may be surprised that the Duralast today is not the Duralast you might have known 5 or 10 years ago.
Very true. I remember when we did the brake one.
Yeah.
You had used the brakes on the white
my
Star.
wife's car. Yep, absolutely.
And, when I looked at them, I hadn't looked at them in a while. I had tested them maybe, about 8 years ago. I put them on my Jeep. and I was not happy with them. But the new stuff is pretty amazing.
Yeah, and it's like, that's like, I mean, these companies are in business to make money, right? No question. When they know that something ain't right and they see it affecting their bottom line, they're going to take action to fix it, and that's what they're doing.
And Pete, they need to know there's a problem.
Right.
Okay,
Absolutely.
that's an important thing. Now, even with your tools, whatever, if someone has a problem with something, they need to give the feedback, not on diag.net and IATN or whatever. I mean, that may get looked at by one of those big companies.
Yeah.
But really contact the company.
Oh, yeah.
You're not only going to help you as the tech or a shop owner, but you're going to help many others. And that's what it's all about, helping each other, right?
Yeah. And I got to give a personal testimony on their last, I mean, if you guys watch me on Facebook, you know that not too long ago, I got back from a cross-country trip where we had a few challenges, I can speak. One of them left me on the side of I-90 in Montana, and I had the AARP, and I had the AAA, and I had all these different supposedly helpful roadside assistance dealios. And the one that came through? It was the one that I got from owning a Duralast Gold batteries in my vehicle. The Duralast Gold Series batteries and their Gold Series components, like I'm going to show you tonight, they come with a 5-point roadside assistance, and they were all set to help somebody up there to help me. So they responded. You got to give them props for that too.
And lucky you had some good techs out that way.
We did.
That came out and helped you.
We did.
A great area. I like being out there.
All right. So first, from some routine webinar stuff like we do before the start of every webinar. First, if you want a copy of tonight's presentation, here's the website. Just go to bit.ly. That's one of those little bit.ly things. And just battery webinar. Type that in, and you will be able to download a copy of the handout, the slides that we're using tonight for your own notes. If you don't happen to have those handy, you're able to print them out as we get started. No worries. You can always just take some notes, piece of paper, pencil, and write them down.
No doubt.
And then I think tonight you can figure we'll probably be here. Well, we always say maybe about 90 minutes, but we never make that limit. We tend to talk a lot, but that's okay. Hey, when you're done, right where you signed up on your account, you can go back there, and this part of the bottom is going to be active. You may see it when you first sign on that, when you complete it, you come back and type and print out certificates. So when you're done, go back there and you can click here and then you print out that certificate for attending. And that way, if you're an educator, you can use that for your continuing education credits. And if you're just tech shop owner, you can, you want to do the little thing, or wait a minute.
Magnify one more click.
There we go. Look at that one there. So there you go. Now you can, and you can go over there for that. You throw me off here. All right. If you have any questions, type them in the chat. We'll do our best to answer them as we go along. But as always, we don't know everything.
Nope.
But we are fortunate enough to know really a lot of smart people in our industry that we can get the answer from them. So there are email addresses. There's mine. Make sure you make a note of that. And let's see if I make sure I got my buddies right again.
Correct,
right? Well, that'd be because I just borrowed the slide from the last one. But, so we know we got that one right, okay? All right. Here's what we're going to talk about tonight. No, I don't want to. Well, yeah, but no, she's come later. All right. So we'll start with batteries. Get up there. I think she's not. If you got the slide on the screen, you can see it. What am I doing?
Challenges.
Batteries. You got the challenge of battery technologies today. Common service mistakes that guys are making all around the country. And this is from the people who make the batteries and are getting them back, and there's nothing wrong with the batteries. Battery testing. We're actually going to show you 4 different ways to test the battery. And we're going to do a brief explanation here, and then we'll go on the car and actually do it on the car.
And let me explain one thing here, Pete. Common service mistakes. When you condemn a battery, did you check? And we've seen this multiple times, including we had an X5 BMW that I made a little video years ago. There was a proximity sensor that is basically how the door opens or unlocks. Well, it went to a BMW dealer. They sold this lady a new battery and an alternator. She went back a couple of times. They switched the battery out thinking it's a battery problem. Let's not forget about parasitic draw.
Oh, absolutely.
Okay, very important. Don't just condemn the battery. Or maybe that alternator was bad. I didn't see it before. If the alternator's not charging, we like to be at least 1 volt over what the battery is at, either 12.6, 12.8. You want 13.6 or 8. If not, don't just condemn the battery. That seems to be a big mistake.
Yeah, sometimes the battery is the bearer of bad news, but it's not the cause. Right. So like with anything else, make sure you dig deep enough to figure that out, right?
And on today's vehicle, when we have NVLD, natural vacuum leak detection, you could have a parasitic draw because it does it when the car is off. You got to make sure it's timed out when you're checking it, and did it really go off?
Right.
It's like when I close a refrigerator at home. I always wonder, do those lights really go off? Now, my fat ass won't fit in the refrigerator. Besides, Doreen would kill me. But I'm always wondering, does that light really go off? Well, all you need to do is take an amp clamp. You can see the current with the door shut and with the door open, and you'd be able to know.
There you go.
So that way my ass doesn't go in a refrigerator where it doesn't belong, right?
After we do that, we're going to talk about starting systems a little bit. Primarily, who's really in charge of operating the starter? It's like that's almost every system on the vehicle now. You're asking a computer for permission to do something. You don't have direct control.
Oh, you
anymore.
can't go anymore?
Not anymore. Well, you can. Is it the problem with the starter, or is it a problem with voltage drop? So we're going to show you how to perform a voltage drop test on the starter motor circuit and something else. We're going to show you how to check the cables when you know for sure that the starter is shot and you want to complete your diagnosis. How are you going to check those cables that the load you need to use is no good, won't work? We'll show you how to do that too.
And speaking of cables, not to forget, do not use those emergency end cable ends, the ones where you cut and then bolt the thing in. That is VD at its best, okay? You're asking for trouble there.
Absolutely.
You need to make sure, cut the cable back to a spot where there's no corrosion left in that cable. And then you're going to need to put a piece of heat shrink, lay it back flat for a while, and then crimp the cable. And also, a lot of people use the stuff that they put the little pellet in there and you heat it up.
Yeah.
The problem I've seen with those is if your starter or engine is pulling a lot of current, it desolders itself.
Oh, interesting.
Yeah, I've seen that on more than one vehicle. Okay?
Yeah,
so
makes sense.
We use the big crimper pliers, or you could use the other ones that you could use a pneumatic gun on or a regular ratchet. Then you would put the heat shrink over it and make sure you got a very good connection.
Absolutely. And then from there, we'll move on to the charging system. Again, we're going to focus on performing a voltage drop test on the alternator system. And again, show you a couple of ways of doing that and which one might be the better choice of the two that we're going to show you. And while we're in there, we may do a little combination, that battery starting charging system scope test, show that a little bit as part of the testing methods. And then we'll dive in a little bit and talk about AC Ripple. I bet you know something about AC Ripple you don't know, but you'll have to stick around and find that out.
I'm going to bet on him.
All right, let's go ahead and get started. I wanted to put this sample picture up here. You saw it on like the cover promoting the webcast tonight. But guys, you've heard me say this and heard Ms. Trulia say this numerous times. You're the professional. When your customer brings a vehicle to your shop, or if you're working for someone else and you're the tech in that shop, ultimately you're the professional that they're entrusting their vehicle to. They may not come right out and say that, but it's like going to your family doctor. When you go up there and I got a sore throat, and you go to the doctor, you kind of expect the guy or gal to make sure they check you all over and point out anything that you may not know about, right? It's the same here. You're the professional. Your customers are not expected to be experts in the field. You are, and you should give them every benefit of your training, your experience, your expertise, and helping them. And it's not just about helping them get the most out of the vehicle and to minimize their cost of ownership, but it's to protect their family. Think about it. If you have a problem and you don't diagnose or check the battery condition, for example, and they find themselves stranded somewhere in the middle of nowhere, maybe it's not the best of neighborhoods, and she's alone and it's dark. You see where I'm going with this? You have to think in those lines. At least I always tried to do that.
Yeah, Murphy's Law, it's going to happen at the worst time. And what's the heart of the whole electrical system on today's vehicle? The battery.
Yep.
And let's not forget, 12-volt batteries are still in even EVs.
Yep.
You know, it's not just that big battery pack. It's a regular battery. So we still need to know how to test it and make sure it's good.
Yeah. And we can show too that a lot of these systems that we're focused on as the primary have impacts on other systems of the vehicle that can lead to unnecessary cost of repair or failure that doesn't have to happen, right?
Correct.
All right, so let's start talking about the challenges. All right, the vehicles that we service have become increasingly electrified. I think we all know that. I'm trying to remember what the number I heard was. I want to say it was the next 5 years or by 2030. It's not that far away, guys. 30%. 30. That's 1/3. That's 1 in 3 vehicles on the road will be hybrid or electric powered. I recently did a diesel presentation that I mentioned just some background on. I want to say the last quarter of last year, which was the last sales numbers that I had available, hybrids outsold diesels significantly. And all those that are sold, down where I'm at, redneck country, we like our trucks, right? So we sold a lot of diesel trucks, but hybrids are actually outselling diesels now.
And let's not forget, there are hybrid trucks as well that have diesels on.
Yeah.
I mean, we use a lot in the New York City area because you can't idle a lot. So utility companies using them. Again, we're dealing with electric, and they're all going to have 12-volt batteries.
And I think the biggest thing that maybe you're not aware of on the everyday, taking care of your customer vehicles, but already major fleet companies, I'm talking about UPS, I'm talking about Amazon, a lot of these big companies are incorporating a lot of EVs into their fleet when they're doing the urban markets, for the cost savings and the lower maintenance costs. So they're coming. They're not coming. They're here, but they're coming in a lot faster. The redcoats are coming. Yeah, the British are coming, right? That's what it is. Okay. Anyway, so the electrification of automobile is also creating a lot higher electrical demand on the battery and charging system. But this creates a negative impact on fuel economy because the power that we use to drive the wheels has to be diverted to drive the alternator. So you're going to see a lot of things that they're doing differently now they want to keep the battery up to where it needs to be, but they want to do it at a minimum level. So they're not taking anything away from the engine that they don't have to.
Let's talk about a Ram that we had in here recently, a Ram with a 48-volt system. The 48-volt system is basically a big belt alternator starter. So you have our conventional starter that's going to start the engine up, and this was a Hemi, okay? Start it up when it's cold, but once that engine has been warmed and reaches a certain temperature, rather than stop beating the hell out of the starter motor, right? Every time you come to a stop, it's going to shut down, save fuel, save pollution, and then start it up by this BAS system, and 48 volts is behind it. Another reason for 48 volts is, you've all seen this if you've done an OBD2 scan of the monitors. Heated catalytic converter.
Yeah.
But they probably haven't seen one, right? Well, with 48 volts, they could heat that catalytic converter up. So you're in closed loop all the time.
Yeah.
So if the gas engine stays around, you're going to be seeing much more of that.
Oh, absolutely. I mean, all the technologies today, guys, are to get the maximum economy and fuel mileage out of these engines. I think the target is still in place for 2025.
Yeah.
So we're in the 23 model year. So we're only talking a few years off now where they have to hit what's called a corporate average fuel economy, which means the average of every vehicle they sold.
54.5 miles per gallon.
Almost 55 miles per gallon. That's why you're seeing what you're seeing changing under the hood on the gasoline cars. That's where GDI came from. That's where start-stop came from. That's where now, of course, the growth in EVs, all to that end. And like you were just saying, that's another big challenge that today's batteries have to meet is that start-stop. I mean, think of the soccer mom, driving in town and is constantly starting and stopping that motor.
And not all vehicles are allowed to shut off. Like GM, for their CAFE, corporate average fuel economy, they made a deal with the government where they are not allowing the driver to shut off start-stop. It is automatic on that car. Now, some other vehicles like BMW, whatever, they're going to pay a fee if they don't shut it off. But GM, of course, would like to shut it off, but they rather get the credits for the corporate average fuel economy.
Absolutely. Now, as the battery gets older, we understand that the internal plates, of course, they start to degrade. We all understand that. and more current is required to maintain its overall state of charge. But of course, that also figures into the battery management strategies that we're going to talk about. Another feature that we talked about already, the start-stop function, and that's a new demand on conventional batteries, and the ability to withstand more frequent cycling of the batteries. Now, what is cycling? Hey, I'm glad you asked.
That's it. Look at that. We have it.
Cycling is the cycle of charge and discharge that a battery goes through, especially when it's depleted by the requirements of the starting system. Think about it. What's the biggest demand on that battery? And that's when the starter's engaged, a lot of current being drawn very, very quickly, voltage being pulled down very, very quickly. That has to be replenished. Okay, that's just one discharge charge cycle. Look at start stop. How many discharge charge cycles during the course of an average day for that average vehicle do you think there might be? Just dozens that I can think, dozens. Yeah. And that puts a tremendous strain on that battery. Now, to address the need for higher cyclic durability and more starting power, improved battery designs have been developed, and you're probably familiar with at least the first one, the AGM, or the absorbed glass mat, and then the EFB battery is another one in that market. So here's just a cutaway of what the absorbed glass mat battery looks like. Absorbed glass just means that the electrolyte is in a saturated fiberglass mat that's in between the cells. And the whole reason we have that is so that the electrolyte can be stored within the glass mat and allowing any gases given off during charging stay in the battery. It's a truly sealed battery. So the idea is, if normal course of charging, of course, we're going to give off that gas, we're going to give off that water, and this way it stays in the case and it can be recombined, so none of the water is ever lost. All right.
And this is another reason why any vehicle, this is a SAE standard, any vehicle where any battery that is inside a vehicle, I should say, has to be an AGM.
Yeah. If
it's outside, it could be a regular wet type cell type of battery, but anything that is in the car, including the trunk area, must be an AGM battery.
Absolutely. Good point. Now, AGM batteries are typically fitted as OE equipment in higher end vehicles equipped with the start stop. And of course, some of the hybrid vehicles, like you just pointed out, it is required if the batteries are mounted anywhere in the interior, whether the trunk or cabin area. Of course, it has to be an AGM type battery. It's a safety measure required in order to prevent passenger contact with battery acid in case of a collision or an accident, right? Next, AGM also offers improved performance over conventional flooded cell designs. It offers 4 to 5 times the cyclic durability. In other words, this battery can take that kind of punishment much, much better than a conventional flooded cell battery. And typically 16% higher starting power, even at lower temperatures.
So, Pete, you mean this is just like marine type batteries are a totally different battery than a regular lead acid car battery, right? Or wet cell. They're all lead in them, but so different battery technology for different type of use.
Absolutely. Absolutely. Now, this is something we really kind of want to stretch on, because again, you deal with batteries and these systems on a daily basis, and you probably think you know them in your sleep. But I'm going to share one of the things that we are learning from just talking to people that make the batteries and what they're seeing out in the field. You have to understand, with an AGM battery, charging voltage is critical to maintaining the health and condition of that battery. Okay, it is entirely different than a conventional flooded cell battery. It's called a recombinant design, which means that the oxygen that's normally produced on the positive plate of the lead acid batteries recombines with the hydrogen, gives off water, H2O, and then the recycled water keeps the electrolyte level constant, right? We just said that, right? It all stays inside in the case.
And that's why you can't add anything to those batteries.
Yeah, there's no way to open it. No way to open it. And they sure as hell don't want you to. Now, here's where I want to make sure you're listening to what we're saying. These batteries have a pressure relief valve, a sealing vent, if you will. And I figure they call it VSLR, some fancy name.
BMW uses a tube connected to the battery to vent it.
Well, now that's there if it blows off. The idea is it's not supposed to blow off, okay? There's a safety precaution for something should happen so the battery doesn't blow up in the car. It's a safety relief. However, here's what's happening in the really real world. You're installing an AGM battery I tell you, because this is like popular down in the neck of the woods where I'm at. When we got all them good old boys out four-wheeling in the woods and them trucks, and they heard that and my Jeep forum at, you can get these things called an AGM battery, and because they're matted, you can beat the hell out of it, and it ain't gonna crack or spill acid anywhere. Problem is, the charging system of the truck they're putting it in isn't designed for the AGM, so it's charging it at too high a voltage rate. What do you think it's going to do to that H2O, that water? It's going to start to boil that up. It's going to build pressure. It releases from the vent. And then when the vent closes up again, guess what? The electrolyte level now is too low. And it's going to be just a short matter of time before that new AGM battery that guy wanted in his truck is just going to be a big black plastic box of junk that's no good anymore.
Let me add one other thing to that. So registration, as Mr. Pierre knows for many, many years, battery registration, or programming, if a battery has been changed for a different design, is super important just for what Pete said, the charging rate. If we don't register, it doesn't know that there's a new AGM in there and thought it had the old one. Well, what did the computer learn? Hey, this battery's weak. We better keep a higher level on it.
Yep.
This is another important reason why all of your scan tools nowadays, we did one a long time back, maybe a few years or more, where Pierre and I connected to Pierre's car, and you were here, Pete, and we registered a battery on a brand new BMW at the time. Yep. So you could do that, and it's not only European now. We did it on a brand new Ford vehicle the other day, and one on a 3-year-old Ford vehicle, and everyone and their mother is going to be doing it. Why? Because they want to make sure the charging rate, they don't want to overheat that battery, as you stated.
Right, and again, the whole purpose of that it's all part of that battery management strategy. As G pointed out, the battery ages. It requires more charging voltage to keep it where it needs to be, especially when we have to replenish what we took out every time we stop the vehicle at a stop sign or a stoplight. All that's got to be put back in. As the vehicles now, they will actually tell the driver when it's time to replace the battery because it knows it's reached the end of its useful life. So, guys, if you're not used to working on Euros, this may be entirely news to you. Go to your service learn procedures, things that we always tell you guys, and so much more so today. Like I said earlier, it's either right or it's not right. There's no gray area anymore. The basic things that we took for granted that we could do in our sleep, you now still have to go to your service information system. You have to read up on the OEM process and procedure before you do something. If you've never done it on that year, make, model in your bay, take the time to, as my friend likes to say, RTFI. What is that?
Read the freaking information. And All Data is definitely a great place to find system description and operation.
Yeah.
Okay.
This isn't the comment here. I'd like to add something. I like to print. I got 55 years in the industry. I still like to print the procedure out and use it as a checklist.
Oh, that's a very good point. Now, of course, now you're an old pilot, so you're used to checklists, but that's a great point. When you're doing something, and again, if it may be a more involved procedure, what better way to make sure that you don't overlook something that could come back and bite you in the backside? And I'll tell you something else. While you're looking in your Scan Tools service function menu, you're going to be surprised about a lot of things that you have to do on a new car or when you're changing a component that you didn't think you had to do before. That's just a little teaser.
Like the oxygen sensor heater.
Yeah.
A relearn.
Yeah, absolutely.
And that's out for years.
All right, next on is the EFB. That's the enhanced flooded battery. Again, there's just a illustration of the construction of that design. This is really a modified, improved version of the conventional flooded cell battery, but it's not a flooded cell battery. You'll find this typically used in entry-level vehicles with start-stop technology. And I don't know how long this has been around, but it hasn't been real long, maybe a few years, because what I found early on doing an article some time ago on this topic from the manufacturers is that not every market had the EFBs in stock when the vehicle needed a replacement. So shops were putting in conventional flooded cell batteries in their place. Oh. You can't do that, again, because this battery is 30,000 starts from a conventional battery versus 270,000 engine starts on an EFB battery. It's, again, that cyclic durability that the conventional battery can't match.
And there's the word, the start-stop system. let's not only forget the battery is different, and so is the starter motor.
Yeah.
The starter motor is a heavier duty design that you have to make sure you use. So the battery is, like I said earlier, the heart of the system. You have to make sure that you have the right battery. And that's a good point. So how would one know they have an EFB design? Is there a marking on the battery? And look at that.
It says it right on the battery.
See?
Oh, isn't
Oh,
that
but hold
amazing?
it. I have to read.
I think we're probably going to touch that again, but since you brought that point up, I do want to say this. Well, I'm not going to say that. We do have it coming up. And there you go. The number one common service mistake: failing to properly identify the type of battery prior to its testing, service, or replacement. Most common mistake that technicians are making out there in the field right now is not identifying the battery type, the construction type. This is critical, guys. You've got to use the same type, and you've got to use the same group, and you've got to use the same CCA rated battery. Back in my day when we first started, if your car came with a 500 cold crank amp battery,
go with 1,000.
You could say, well, if I got 1,000, I know that baby will start, and you put the biggest thing you could fit in the battery box. That is not the case today. We have a comment, question?
Yeah, actually, somebody had a problem with a new battery, but I wanted to illustrate this. He said he got 2 batteries and tested them, and one came back with 20% of its life left, brand new battery. It's a good idea to test your batteries before you install them in the car.
Definitely.
That's a very good point.
The batteries we have here are always on a maintainer, and we do test them before we put them in and after. Why? You could get something defective, whether it's an OE battery, whether it's a Duralast. Make sure you check it. And let's not only check the battery, but how about the starting and charging system? As we're going to go through on this, the complete system works together, hand in hand.
Yes, that's a great point to keep in mind. And just like Pierre just said, guys, that's just common sense. Depending on who your parts house is, it's not the quality of the part, but sometimes it's the management of that individual location. They're not properly rotating their stock or maintaining it. Like G said, he keeps batteries in-house. They keep them on a maintainer to keep them healthy. So, yes, very valid point. Thanks for bringing that up. All right, number 2 on the hit parade. Most common mistake, using an old high-powered charger.
I can't use Daddy's old charger for that Plymouth. It's been in the shop for years, Pete. What the heck?
Well, you know what? We kind of giggle about that, but let's be real with each other. Having both of us travel around the country, been to a lot of different shops around the country, been to schools where we even have the wrong stuff, antiquated equipment in the shop. And again, you say, well, it's a battery charger. It charges batteries. That's, today you do need a charger in the shop that is capable of choosing between the type of battery being charged and the charging method used. And not only that, but if you're doing any kind of extended work where the electrical system is going to be on for a while, or you're into programming vehicles, then you should know that you need a special charger called a battery maintainer. They are 2 different animals, and you can't replace one for the other.
You could get a combination one that Medtronics or what's the one?
Associated?
Associated, right?
Yeah.
We have them all over the place. Associated that charges that. And a real quick true story. So when Priuses first came out and they use an AGM, New York City made a mistake. They had their old battery chargers by a nice red name brand company. They needed to update. Okay, yeah. They didn't. They were starting to charge these batteries up and have problems with them. They were ruining brand new batteries until, I seen their issue and said, hold it, you can't use that charger. Yeah, but they're brand new from the red guys.
Right.
It's really good. I said,
right.
Not for this application.
Right.
That's why you have, Associated and or Medtronics and other companies, Snap-on now as well, that are using batteries, chargers that are pulse modulated. They're not going to put a full charge in and burn that battery up. Case temperature should never go over 125 Fahrenheit. And if you don't pulse it and you just get a wicked hard-ass charge in there, well, you're going to have a problem with that.
Yeah, absolutely. Absolutely. And I want to go back to the first one again, because we kind of hinted on the replacement, but this applies to your testing, guys, as well. And we're going to show you that when we demonstrate the testing methods. Anytime you're having to do any kind of service, inspection, repair, whatever, make sure you identify the battery type. Number 3, we kind of hit it out already, installing the wrong battery for the application. Very big deal. In fact, it's one of the things I would encourage you guys when you're having some type of weird electrical stuff going on or drivability issue. We're going to show you the first thing you want to check is the battery regardless.
Right.
But while you're checking that battery, note the size, the age, make sure it's the correct one for the application. And if it is a vehicle that is coded or programmed, go in the scan tool and see, does the code match the battery in the vehicle? For example, if you got batteries that the customer's going through batteries every 6, 8 months, 9 months, then maybe it's because it never got properly coded, and the charging the PCM still thinks it's the old battery, and it's throwing a full ass charge on it, and it's cooking the batteries unintentionally.
And we had one, a Q5 Audi in here that came from the dealer. This is no bull. I was amazed that they did not code that battery. Okay. Just because someone works in a dealer doesn't mean, number one, they went to all the factory training,
right?
Or number two, they're trying to beat the clock. Okay. And there's nothing wrong with trying to beat the clock, but you got to do it the right way.
Right.
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 So they can ruin the battery. Go ahead,
There's a number 3 as well, and that is they got 3 cars to work on and they're distracted.
Yeah. Well, and I think it's true anywhere. Yeah.
And that can happen.
We all had that when I was serving full time in the bays. It's like, and we understand the boss is on your case, but is your boss going to be happier because he's not seeing the same car come back in for a freebie because the first one wasn't done right, or that he's seeing his customers increase because, hey, word's getting out that when it comes to you, it's done right. You think he's going to be happy about all that? He'll get over it, So take the time, like you said, you're either fixing it right, fixing it wrong. And I'll tell you something else that I've said before, and I might get in trouble for it, but that's okay. I've gotten in trouble before. I get calls from guys, and we see it all the time, who say that our shop doesn't support us in getting training. We don't get the time off. They don't have us any credit. Whatever. They're not supportive. I'm not getting paid enough. The working conditions, whatever the case might be, guys. Right now, you're in the catbird seat. Especially those of you who are taking the time to be listening to this webcast, because you're that small percentage of the whole that wants to be more professional, wants to improve their skill sets, wants to do a better job, and you are in high demand. So if there's a shop in your community you're not happy with where you're at, I'm willing to bet there's a shop in your community that's dying to see you come in the front door and talk to them.
You bet.
I know one in Mahopac, New York.
Right. Very correct.
Right. Yes, sir.
The question is, how about battery chargers that have a setting for EFBs? Is there a difference? Are they available yet?
EFBs are certainly available. I know early on it was like just for the market, but that's been a little bit ago now. So EFBs should be readily available at your parts house. Of course, Duralast, of course, can supply that. The charger batteries, yes.
They have a special EFB one.
Oh yeah.
Oh,
I know it's
I just learned something new. I
have a Chlor Automotive charger I've had for a while now that has EFB as a selection on it.
Wow. Okay.
Yeah.
You know what? So, I think that new associated one may have, because that's a menu screen. I know the older ones don't, but that one may have it in there.
Yeah. And a lot of guys who have the newer stuff, you may not realize it's in the menu simply because of the fact you're not getting that many in yet. You know what I mean? Right. Generally, you're seeing conventional and AGM as the majority of the service that you're doing, but we want to make sure that you understand that there's a third one out there that's a player in the game. So just be aware.
I'll just give another tip. We talk about batteries being the wrong ones or being weak. If you get a hybrid vehicle, such as we'll play with a Prius, if the battery itself, the 12-volt battery, is not up to par, whether it's the wrong one or it's weak, you are not going to get the proper miles per gallon out of the vehicle. And you go, what do you mean? Well, the system, the way it works is that small 12-volt battery operates the 12-volt system on that car. The electric motor produces energy that goes through IGBTs, integrated bipolar transistors, in the inverter that basically is going to change AC to DC, okay? And it's going to go through the converter part of that as well, and that is the alternator to charge that battery. If that 12-volt battery is weak, guess what it's going to keep doing? Robbing power. And if it's robbing power off the big battery,
right?
Well, guess what? The gas motor is going to run.
Yeah.
And you're going to get less miles per gallon.
Yeah. Yeah.
So that's a biggie that people forget about.
Yeah. I bet you on the EVs it's probably even more so because now you're reducing range.
You
Right?
bet.
You don't have an ice to back you up if you're
That's
too
why Pierre asked, "What's that thing you got in there?" I said,
low.
"I have, rather than the gas can and a gas generator, I have an electric powered generator."
Yeah, absolutely. All right. A few additional notes for you. It used to be thought that an AGM battery could be used in place of a flooded design, but information from the field, of course, is proving that's not always the case. We gave one kind of blatant example about misapplication, like in a four-wheel drive application or truck, to make sure that the charging rates are not the same. An AGM battery is more susceptible to damage caused by a mismatch between the battery and the charging system. If it's installed in the engine compartment, it can also be damaged by the high heat load there because they're really not designed for that application. So instead of providing your customer the battery that should last longer, you're really just setting them up for an expensive and premature failure. Same is true for EFB batteries. Shops, like we said, are substituting them with the conventional designs when they don't think they can find one, or instead of waiting or ordering the proper replacement battery. In fact, Nissan even issued a TSB noting that their models using an EFB battery had to be replaced by a specific OEM replacement part only. Okay, so just make sure. How you know that? Hey, I RTFI'd because I learned to RTFI from this guy over here. Okay, so. All right. Some of this is going to be some recap and reinforcement of some of the things we've talked about so far. Again, a lot of vehicles that you're working on now have a battery management strategy. It's only one small part of the things that the engineers are doing to these vehicles today to reach that CAFE requirement and to make these engines more efficient. As early as the 2002 model year, they've been incorporated in many vehicles. The whole idea is to create a fine balance between maintaining the battery's ability to provide the needed power to the various vehicle systems while also reducing the power loss to the engine that would be caused by running the alternator. And just to reinforce, the battery gets older, the internal plates, of course, are going to degrade. It's going to take more current to maintain the state of charge. The ECM learns that, but unless we tell it that we put a new one in so it can reset and start from scratch, you're going to end up having problems with the battery.
You bet.
Now, coding and programming, a little kind of different.
Definitely.
Right?
Definitely different.
So coding, it's like, okay, I just got to tell the ECM I put a battery in it.
And it's going to date it and so on.
Give a couple of blanks in there. But this actually has a code on the battery. Whoop, come on, there we go. That you have to either scan that little QR code or you have to put that number in there. You can see there's the BEM code. And that is going to be a part of the step when you program the system. Good thing is a lot of the higher end aftermarket scan tools have that feature in them, so it's not a problem for you.
Right. You get cameras in them, they can scan it and put it right in and show you that you need to put that in.
Yeah.
But these are things that either people don't know about, okay? And that's why when Pete said you're going to learn a couple of things here, you are, okay? You're going to pick some stuff up that maybe the way we do everything every day is not what we should be doing today.
And I'm going to, we don't have a lot of delay, but I'm going to ask a favor from all you guys who are watching, okay? So far, just when we showed you on some of the things, the nuances of battery service and inspection, if you've picked up one thing that you haven't heard of before or knew of before, I don't care what it is, would you type a Y in the chat box real quick? And if you...
I'm going to make a Y because I learned that thing, the one thing before.
And if you said, no, so far it's all old hat to me, then type an N. And I'm just going to wait a minute. I want to see what kind of response we get from that. It's only one button, guys, so,
get the finger exercise.
Push the button in there. Okay, look at that.
Oh, look at that.
Wise.
A lot of Ys.
Thank you.
All right, thank you very much. A lot of Ys. Hey, thank you so much. We appreciate that feedback. And again, that's why we do these webcasts for you guys. And if you've been around with us for any length of time, we've been doing this for a long time. And that's what gave birth to this whole concept of coming out in the shop and doing these informational broadcasts so that you could get the information that you need to succeed. So thank you. I really appreciate that. All right.
We do. Thank you.
All right. Service tip. If you noted that the battery you're replacing is not the original battery for the car, I mean, it's not the factory design, it's got another branding on it, whatever it might be. and your customer's complaining it was only last year or so ago that they had that one installed, like we said earlier, check your scan tool data, go into that BMS menu and look, has it been updated? You know, if you see it's never been updated, then it's a good bet that's the cause of your problem. You know, so use that.
And don't be discouraged on some of the scan tools. Now, some of them really stick it right out there.
Yeah.
You're going to know here's battery registration and whatever.
Yep.
Others, they're buried. Do not be discouraged. I know this just happened in the shop probably 2-3 weeks ago, where a particular scan tool, won't mention the name, they had it hidden in a couple of menus.
Yeah. Yeah.
So it's there. Factory tools usually a lot easier, but I'll give Autel and Snap-on both the plug and launch. They have them
right
in your face.
Yeah, I mean, I think it's the service function menu.
Yeah,
and it has all of it in there. So it's just, again, check it out. And while
know your tool.
Yeah, and while we're talking about that topic, the next time you have that tool hooked up, whatever you're doing to the vehicle, 2 things I want to encourage you to do. It's a little off topic, but I'm going to throw this out here anyway because it has to do with being a professional. When I was raised up in the field, you were taught to do a visual inspection, check the oil, check the fluids, kick the tires, look at the brakes, you know, that you could. Everything you could to just kind of get a general feel so you could tell your customer, give them a good idea what kind of condition their vehicle was in. But now, I think the average vehicle has like 40 computers on it, higher end, 200 plus. Your vehicle and your customers' vehicles are more and more electronic. Why don't you take the time as part of that first inspection, pre-scan, hook up to your enhanced mode and do a full system scan? Do a full system scan.
And that's why you can see, as you heard me just whisper, pre-scan the vehicle. First of all, you know what? Running a shop, I can tell you, 2 things you don't want. A customer coming back mad because you just worked on their car and you have not done that pre-scan, okay? Or them getting stuck and getting real cranky, right?
Right.
If you do that pre-scan and you tell them, hey, look, here you got some problems in this system. Yeah, but I only want to fix my engine. At least you identified that problem and told them. It's like this BMW we have here. This guy had a problem. We told him the hoses and the thermostat, all of them, had to be replaced because his oil cooler went. What did he do? He called up the other day. Thank God he didn't get me. He got Bill and, read him the riot act. And Bill said, hold it. We told you you needed all those hoses. You had oil running through your system. It's the same with a battery or anything else. Let them know. You don't let them know.
Absolutely.
They're not going to know. So the visual is great, but the scan tool, that is right on top of it.
And you get a great documentation. You print out the pre, you show them the need, you fix it, you do the post, you got proof you fixed it, and you're covered. I'm sorry, Pierre, go ahead.
And I'm going to add, and if they say no, then you're also covered.
Right.
Just make them initial.
Yeah, you can't make them.
Yes, they have to sign it or initial. There was a question, do you have a recommendation for a battery tester that can also do the resets?
Oh, I'm going to be very careful here.
You better be.
A lot of the tool manufacturers make them. They really do. Of course, we've been doing a lot of work, or Autel has been a big helper on the motor age side, sponsoring our trainer series now for the last few years. And I would say one thing I do like about their tool, the handheld unit, and I think it's incorporated in their scan tool as well. But when you connect to to do your testing, it's not going to do just the testing. It will walk you by the hand in terms of replacement. Why is that important today? You can't just disconnect the battery and put the new one in. It's not that simple anymore. In some manufacturers, there's a very specific procedure they want you to use in order to replace that battery. And if you just disconnect it, every module in the vehicle goes crazy, loses their minds. And if you don't know what's going to have to be relearned, or worse yet, you do the job and then find out after the fact that these things have to be done and you're not capable of doing them, well, now you have more problems than you started.
Radio codes and
say
throttle resets.
Yeah.
But Pierre, how about using a battery maintainer box on a BMW? Oh, if you didn't know that, you shouldn't be doing that because you're going to pop a fuse.
And also on vehicles where the cigarette lighter, for example, goes dead when the ignition is off, your maintainer box just got disconnected when you turned the ignition off.
Oh, well, even nowadays, I mean, way back in the day, we had the 9-volt battery, stick them in the, well, it's not a cigarette lighter, right? It's the power outlet. But back then, you know, we actually had the little, well, no matter. And we used to plug in the 9-volt battery, but you learn pretty quickly that when you open the door and all the interior lights came on, that 9-volt battery went poof pretty quick. And it's not connected to all the vehicle systems. We're going to show you a little bit later on one way that you can do that. But again, that's just one example. I think Snap-on makes a similar tool. Major tool companies, they all have something similar. I encourage you to look them over, compare feature, benefit, and cost, and go what's best for you.
And read the information. The RTFI is super important because just like that BMW I mentioned, you think the jumper box that you use through your OBD2 connector, first of all, is pin 16 have a blown fuse in it. Pin 4 is ground, yeah, but 16 don't have power. You got an open. That ain't going to work maintaining a normal car, but use that on a BMW. It's going to look like an early Christmas. The whole dash is going to light up, and you're going to have to go change your fuse. So read information, or thank you for attending. We're giving you info.
Yeah. One more.
I'd like to add one more thing, and it's for me. You know, Jerry said it a bunch of times. He's going to continue saying, read the information. Every vehicle has a specific amount of time to go to sleep. And you probably should familiarize yourself with that.
Yeah, especially with it can vary quite a bit.
You need to put it to make it go to sleep before you do that battery.
Yeah, at the very least. And again, so and the other thing I want to mention is kind of back to the side note.
That's a good point.
We said about the service learn function, wherever it might be buried on your tool or right up front in your face, like a lot of the bigger names are. I encourage you, when you hook up to that vehicle, you completed your full system scan, your pre-scan. Look at that menu, because you're going to be surprised at some of the things that you have to relearn now through the scan tool that you didn't have to do before. The car would do it automatically after you drove it for a while, or it was a manual way to do it. So many, and so you'll be surprised at some of the things they have in that list that you wouldn't think in the world that you would even have to bother relearning, but you do today.
But we'll give them a good one. If you don't do the window relearns, and it starts raining, like this guy has some of those torrential rains down in Florida, okay? We get them here once in a while.
Yeah.
But if you don't do the procedure they want you to do, put the windows down, put them up, or the moonroof back and forth, you may go out to a vehicle, the windows were closed, but now all of a sudden it rained, and guess what? The windows are open.
Yeah. Well, you actually had a great example right here in your own shop where, you know, the one of the local parts houses trying to be nice, put the battery in for your customer when the window rolled down, and guess what? They put the battery in. Now the window wouldn't roll down, and it did start raining on her, right? So,
Yes.
Yeah.
And she had in the display, it didn't have the odometer reading. It had error.
Yeah.
Yeah.
All right. So let's start with some battery inspection and testing tips.
Oh, this is my favorite thing there, Pete. You got to blow that up.
I wanted to say that. Let's see.
Hang on. I'm going to blow that baby up.
Look at that. Bring that up as big
Look
as
at
you can.
Look at that baby.
And then I'm going to do it even more. Can everybody see that? I know it's kind of corroded.
That's VD at its best.
Yeah. But I want to point out, this is what he was talking about earlier. This is an emergency only battery cable replacement, and it's got that little flat plate and the 2 bolts that you tighten down on it. And
brutal.
The symptom I always saw was that you go to try to start the vehicle, you get one click, and then everything died until you cycled the key again. And then when you go through the same process. But absolutely great example of voltage drop.
Yeah, and it's not professional to use one of these. In an emergency situation, fine. But if you don't have the correct battery tools, go visit, an AutoZone and make sure you buy the right stuff to do it. Or don't do it, or buy a new cable. But this is absolutely a disgrace. And by the way, you see the top of the battery right there? If you did a test on the battery with your meter, you will pick up voltage right from the top of the battery. Leave the negative cable on the negative terminal, take the positive and go on top of the battery, not connected to the positive post, just on top of the battery, and you may read 6, 8 volts or even more.
Well, wonder why that could be, my friend. It's an oily residue on top of the battery, isn't it? Oil's conductive. You just made a path between the positive and negative side of the battery. There's current flowing. That's a drain. That creates that corrosion is not because it's been exposed to the salt air down there in Florida. That's because it's being exposed to battery vapors getting out, and it's not supposed to. You see that? It's not just a matter of cleaning up the corrosion, but correcting the condition that caused it.
That's right.
All right, and there we go. There's a
That's a no
example.
plus.
And yes, these are from Amazon.com. You can buy them there today, right? And they're even color coded.
Oh, that's going to make them better.
Makes them better. All right, first step, as it always, visual inspection. Here's just a few things that you should look for. Like we said earlier, first, verify correct battery type, construction type, group size, and CCA rating for the application.
We should stick in there too, reserve capacity too.
Yes.
Because the CCA goes up, reserve capacity goes down, and that could be a problem on some vehicles.
Yep, absolutely. Physical damage to the battery, of course, any damage to the case or any signs of swelling that could
Swelling
occur.
like this, you mean? My swelling?
Yeah. Well,
Are you talking about my swelling? Swelling is a big problem.
Yeah.
Okay. When you see the case starting to expand, okay, like I have expanded, okay, well, you got a problem. So that is an important thing that people don't look at and that you could actually see.
Of course, any obvious sign of electrolyte leakage indicating a crack in the battery case. Corrosion around the battery cable connections. Again, that's what I said earlier. That indicates a venting of gas somewhere. And these are all supposed to be sealed, maintenance-free batteries today. And that's leading to that. Loose cable connections. Very, very common. Right? Just grab a hold of it and it doesn't wiggle.
This is the God's honest truth. In this very bay, many times doing a class, I go like this to someone's cable. I'm not talking, I'm yanking on it.
Right.
Just a little, dude, your cable's loose. Oh, my check engine light sometimes would come on and off. Well, here's the first place to start. Okay. Very, very important.
And keep in mind, when you're doing voltage drop, it all starts and ends at the battery. So if it's got the problem right from the gate, that's going to affect every system on the vehicle.
One other thing I want to mention, corrosion at the cable on top. But how about when the negative cable is stripped in a spot, like on Fords or Toyotas?
Yeah, Chrysler.
And Chrysler, where it's going down to be the ground to the battery, to the chassis, excuse me, from the battery.
Yeah.
You got to look down there, because if that's corroded, and this was a big problem with Ford Explorers, the top of the battery would look beautiful, but what can go through those cables? And it would go down and you would get a no start condition.
Yeah.
So always take a look. You know, God gave you the brain, the eyes, the ears, the nose, the hands. Use them because it could help you solve a problem.
Yeah, absolutely. And that's something else we want to make sure we understand it. If you have corrosion at the top, well, that corrosion likes to seep right down the cable, and you don't know how far it extends. How are you going to make sure you can check that? You use some fundamental voltage drop tests right before you even start part of your troubleshooting. And I want to say this for you guys. We have done numerous webcasts on electrical testing and voltage drop testing in particular. And I'm going to challenge you to ask yourself, are you truly comfortable performing this type of test? I meet technicians all around the country that still aren't. And that's okay. I was one of them. And so I learned how it all works. And that's why it's one of our passions.
Pete, a couple of people have said your mic has dropped out or something.
Mic dropped out. Uh-oh. Hang on.
Oh. That's the testing.
Oh, you did. You died.
Oh.
Hang on.
Hold on.
Hold on. I'm going to undie them.
We didn't do a load check on the batteries.
I did load check them.
Affect the batteries.
Pop a couple out.
So, okay. Hook me up, bud. You got the clarity correct?
Let's make sure you unmute it. There you go. You're good.
Okay.
He's back.
Now, we're back.
Just type Y if you can hear him better now.
Yeah. Can you hear me okay?
That's it.
Okay. Thank you for bringing that to our attention. That's the beauty of doing these things live.
And I did load test them, for real.
Yeah. No, I hear you. I mean, I was doing some projects in the garage not too long ago where I had audio issue and didn't realize it's like talking about half the video shot. Had to do it every day. Anyway, so kind of recapping what we were saying earlier about the loose cable connections, corrosion passing through the cable ends, voltage drop testing is how you're going to find this. There are a few basic checks I'd like to do before I even dive into the actual complaint when I do a voltage drop test. But the key is you are sitting right now where you've got one of the best resources available to you. When you signed up for the webinar tonight, you are now have a Motor Race training account. And when you're done, go check out the library. Yeah, there's some pay-per-view titles in there, but there's also a lot of free titles in there. Any of them would be worth your time. And now you have access to every single one of them. So by all means, take advantage of those resources. Yes.
You know, you kind of mentioned it, but I'd like to reiterate. When you're doing that whole system or all system scan of the vehicle, look for network codes or voltage codes.
Yeah.
Even if you don't see a problem otherwise.
Yeah, that's very, and of course, that's going to lead you to issues where? In the electrical system.
Your pin 15 problem, Pierre, is that what you're talking about? Or 30?
Another thing
15
is
and
commonly
30.
overlooked. Make sure you look to make sure that the hold downs, the mounting hardware, and the battery insulators that the vehicle came with, all of it is there. It's there for a reason.
Oh, so Pete, you mean when a redneck is driving down the road and the battery's bouncing up and down?
Yeah.
That's going to cause a
like
problem?
on my kid's old truck. Yeah. Yeah. Or they have the insulating casing around there, again, to protect the battery from the heat in the engine compartment.
Very important.
That's what you don't just take those off and throw those away. If it's damaged, replace it as part of the service.
If they're using an insulator for that battery in that vehicle, they realize that under hood temperature is very, very high and can cause the battery to have a problem. Okay. And bungee cords are not good hold downs, because if that thing does bounce a bit, you're going to ruin that battery.
Yeah, absolutely. Absolutely. All right. So then the next step that I like to do is measure OCV, open circuit voltage. It's just a really quick measurement, connected negative to negative, positive to positive with your voltmeter. But I got to throw this in there because you and I are always so passionate about electrical testing properly. Voltage is not a static thing. Okay. I can't, if I could take the plastic out in X-ray, you're not going to see this block inside that's called voltage. It's not a static thing. I want you to understand that when you're measuring with your voltmeter, whether you're just checking the battery voltage or you're doing a voltage drop test or any other kind of voltage measurement, you are measuring the difference between one meter lead and the other in potential. How can I describe that? If you went to OTEC school like I did years ago, we used to be taught that voltage was pressure. And you always had the example of the guy with the water hose, right? With water shooting out of it. And the reason it's shooting out is because it's the pressure. Bull. That's not why it's coming out. Think about it, guys. The reason it's coming out the end of the hose is because there's a lot of pressure behind it and very little on the other side of the hose. High goes to low, right?
Pressure differential.
That's the pressure differential. That's voltage. That's what you're measuring. You got one side's got a whole bunch of electrons, a lot of potential. The other side, not so much. They want to get together, and that potential, that's the difference. It's like reading a map sensor voltage on the engine.
Correct.
Right? Same kind of thing. Okay. So
by the way, there's that battery case cover right there.
Yep.
That is one of them. Some of them are heavy plastic or whatever. Then more of a European type setup on this thing here.
Yep. And then what does OCV tell you? That's direct for the purpose right now. That's our state of health, state of charge on the battery. I wonder where would you, when you do that, before you go any further with your electrical testing, what's the minimum number? Type one in, and we'll just make it easy. Conventional flooded cell battery, like you've seen for years. If you measure that and make the go no go decision to any further testing, what is your voltage level preference? What would you say is the lower you can go?
We're looking for a number.
Yep. What's the lowest you can go before you have to charge the battery and retest? Give you a minute to put some numbers in there.
Tick, 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 tick.
Yeah,
looking for numbers. Looking for numbers.
It's
a few not more, dialing for dollars here.
A few more buttons.
The show was gone a long time ago.
We got a 12.6 and a 12.65.
All right.
Half hour.
All right. So right now we're looking at, for a conventional flooded cell, 12.6 is considered about 90% charged on a conventional cell. That's okay. I would go for that. Me personally, 12.5 is the lowest I want to see on an initial check. And I want to caveat that by saying that if I see 12.5 or if I see less, well, I know the batteries are discharged because it's telling me right here at 12.37, it's a 70% charge.
12.4 is about 75%.
Yeah, that's about 75%. So at the very least, I'm going to pull out my battery tester and I'm going to do a little more deeper test to make sure that battery's okay. You're going to be amazed at how many issues you're going to be able to tie to a problem with the battery. So you've got to make sure that's right first.
No doubt.
All right. Now, as the battery is discharged and charged, the electrolyte base begins to solidify in the plates. It's called sulfation. We've all heard that term. It's a crystallized compound, and it can't be dissolved and it slowly reduces the plate surface that's available for the chemical reaction, and that reduces the battery
I
capacity.
mean, I can't put some of that special juice in there, Pete? I've seen that stuff sold.
Oh yeah, yeah. Refresh my battery juice, right?
That's right.
It's right next to the blinker fluid on the
Yeah.
shelf, right?
And don't mix it up with the 5-hour energy stuff. A little bit different.
So if you do take your original measurement, you might see it's a little higher than that 12.6 number, the 12.7 number. That's just surface charge. You know, I can't speak for G, but for me, you know, when I'm doing these tests, I bring the car in, and then I'm going to shut it off. I'll turn the headlights on for a couple of minutes, and then I'll turn that off, and then I'll take my open circuit voltage measurement at the battery. That should take care of the surface
Right.
charge.
Or some of your automatic testers actually tell you have above a surface charge, and
Yeah.
they'll tell you turn the lights on, or if you have a load tester,
Right.
you can load it down a bit. And if something goes down too quick and bounces up too quick, called battery bounce back, you're going to have a bad battery.
Yeah, that's another indication. Absolutely. So if the measurement is below 10.5 volts, we don't have to go much further. I mean, that's there's a cell missing, and the battery will absolutely need to be replaced there.
Yeah.
All right.
Definitely have a problem.
Now, earlier we showed this picture. Did you catch the mistake made? That I got to give a guy's chance. What mistake do you see made in this? But what's wrong with this picture? And I didn't realize I did this, so I made the mistake. I didn't know any better. See, I can learn a little something. What did I do wrong?
No answers yet.
Yeah, there's a little feedback. We're going to wait. There we can see some there.
Yeah, we probably have a 30-something second or more delay.
Yep.
That was the previous.
All right. Give you just another minute or two.
Where the voltage is being tested is the first one.
Oh, boy, I wish I had something to give the guy. Very good.
Yeah.
Where am I testing at? I'm on the cable connection. You should always take your measurement directly at the battery. In this case, the top posts themselves. If you're doing a side post battery, then you've got to take the cables off and measure right at the connection in there. You can't measure through that connector. Very, very common. In fact, another one of the common mistakes made, side post battery, taking that measurement there, and there's corrosion on the inside that's causing you to get
And a good one on that is the cable end or the lug has those little gripping.
Yeah.
If the gripping pieces that go to the battery itself are all worn down and stuff, well, number one, you're going to need to change that, because basically you only have a bolt going through. That's why they did away with side terminal batteries.
Right. Yeah.
And you got to get to the battery itself. Okay.
Yep.
The battery itself.
Always test directly the battery, not the cable ends. And this is another important. If the battery is mounted in the interior of the vehicle or in the trunk, you cannot accurately test the battery measuring at the remote jump posts under the hood.
That is a biggie, including doing relative compression from those posts.
Yes.
That is not accurate.
Yeah, because you got that entire length of cable that could have any kind of amount of voltage drop issues that are certainly going to affect your reading.
Definitely.
All right. Testing method number one. Again, these are going to be really brief explanations, and then we're going to go in the car and we'll actually do them. All right. So the very first one is one that I wanted to include. It's something that I like to do. I call it the down and dirty test. It just uses the min-max function of your voltmeter. I'm going to go ahead and hook it up. I get my OCV reading. If it's over that 12.5 number I was talking about, well, then I turn on the min-max and I go in and crank the car. Now, I might do that a couple of times, and then I'll go ahead and after that second and third shot, I'll shut it off, and then I'll go out and I'll look at the readings. Obviously, the minimum reading is going to be my loaded voltage. Want to be of 9.6 or better on a conventional battery.
Newer cars with like 10.1.
10.1 on an AGM or EFB battery. And then I'm going to hit max. Okay, then that's going to give me an idea of what the charging rate is. And we've all been taught 13.5, 14.5, right? So let me ask you this. Here's another question for you. I am full of questions tonight.
You're a question man.
I'm the question man. I'm the Riddler.
I'm not Batman.
You're using
Maybe
this
Piero.
technique. If you use this technique and you see that your maximum reading is 17.1 volts, problem or no? If it's a problem, say yes. And if it's not a problem, say no.
Well, you could put P for problem.
P for problem.
And N for no.
N for no. Okay, I like that.
P
So
and
we'll
N.
do it G's way.
P and N.
He's the boss. P
Not
for
a P and
problem.
L.
P for problem, N for no problem. If you saw a max recorded voltage of 17.1 volts. Is that a problem or not a problem?
First one up is a P.
All right, so we got a P. A lot of P's.
A lot of PP.
A lot of P's. Okay. Now, see, that's why I said why, because it's like I don't want to see a lot of P on the
PPs.
monitor. But
You know, we have that
God,
problem.
see, that's why you guys come to us, because we just got them. We're just rattling them off one after the other tonight. Okay. Let's see. We got. Okay. So one of the guys says, I already heard this one. I got to pass on answering because I know the answers. Thanks, Don. Good to see you, Don. I'm glad you came out. All right. So I'm seeing a lot of P's. You know what? Sorry, you would be mistaken.
Right.
When we looked at, again, we talked about battery management strategies today. If you didn't RTFI and realize that in order, especially start-stop vehicles, we got to put that juice back in that battery right here, right now, right quick. And this is one of the ways they do that. For maybe the first 20, 30 seconds, they'll have a high charging rate of, say 17 and a half volts.
Yeah, 17,
But then,
17.
then
I've seen
back
it.
that off.
I've seen it on my Corvette many times because I leave it sitting for a while.
Mhm.
And when I get in it, you'll see it go up and it duty cycles that charging rate, and then it'll go down.
Yeah.
Reason being, the battery's been sitting there a long period of time. It sees it's depleted. They're going to try to get that battery up to snuff.
Yep.
And you notice we got a lot of current sensors on cables nowadays.
Yep.
So it's like your Medtronic tester, conductive resistance. They want to get it in there. Years ago, we would say, hey, it's a bad regulator. You're
Yep.
going to overcharge that battery, but it does not do it for a long period of time.
And that's actually where this popped up when I was still working in the bays, and this was on a Jag, and the guy put a new
Get the
alternator.
holy water out and jack.
He saw that and he put an alternator on it, and guess what? It didn't change anything. Because why? He didn't RTFI. That's why
Gotta read that
I keep
info.
stressing, and you're going to hear, if you come and watch this, you're going to hear more and more of this. Today, it's either right or it's wrong.
Hey, and you know what? They just learned another new thing.
Yeah, look at all the P's there. And I got to be honest with you, because and I'll get to here in a minute there, but I got to be honest with you too. If you did say it was a problem, then you're kind of right, because the only way you're going to know for sure is if you go back and read up on the theory of operation
Right,
for that
certain
year, make,
vehicles, it
model
would
that
be.
you're testing.
Correct.
Right. Okay. Sorry. Go ahead.
The
Pierre.
same is true in reverse, by the way. There are a lot of vehicles today that will not charge the battery at all at idle. You'll see 12.6 or 12.0 volts.
Right.
That's
Good point.
normal.
Good point. Thanks for bringing that up here. So if you couldn't quite hear that, the opposite's also true. You may get no max, and you may say something's
Exactly.
wrong.
You
You've
may
got
be
to go
under the 12.6 or
below
12.8
13.5.
below it.
Yeah.
Because he just doesn't see that it wants to charge it at that particular point
Oh yeah.
for whatever
Yeah.
reason.
Yeah. All part of the battery management strategy. All right. All right. Test method
there's that
number
guy. We
2.
know
There's
him.
that guy. We're going to talk about this. I'm going to show the video, and then we'll talk about it. All right. Take a listen. Like this one. Many shops are still using this tried and true testing method, but the question is, are they doing it correctly? Before we can perform this test, the battery must be fully charged. According to the BCI specifications, that means a well-rested voltage of 12.6. But what does well-rested mean?
No
Well,
video,
what that means
no
is
sound.
that
with
even after sitting for 24 hours since it last saw a charge,
No, he got it back. He
the
just said, "Oh,
battery
there
is
it goes."
still reading 12.6 volts. It's also important to test directly at the battery, which requires disconnecting it from the vehicle. But before you do so, install a memory saver like this one to ensure that the memories of the various control modules remain intact. And if the battery is a side post design, be sure to use the proper adapters to ensure a good, clean connection between the battery and the tester. The load test is designed to mimic the electrical loads placed on the battery by the vehicle. And rapid heat buildup can occur in the battery, especially if the load is applied for too long. This could result in damage to the battery, even the possible chance of an explosion. So always make sure that you wear the proper personal protective equipment. A full face shield like this one offers a lot more protection than safety glasses alone. To perform the test, first determine the cold cranking amperage, or CCA, rating of the battery. This information is usually located on the battery label. Connect the tester and apply a load equal to 1/2 the CCA rating for 15 seconds and note the voltage. Conventional lead acid batteries should remain above 9.6 volts, while AGM and EFB batteries should remain above 10.1 volts. All right, guys. I see you guys make comment about the volume on it. Okay. And some didn't, so I'm not really sure if it was across the board or not. If it was, I apologize for that. However, you can always access this information on the Motor Age Magazine YouTube channel. That's where this video is housed, and see it again. Essentially, we're looking at tried and true method of battery testing. That's the carbon pile load tester that many shops still use today. But as mentioned in the video, if you didn't hear it, if you read the standards set forth by the Battery Council International, they tell you that that battery has to be a well-rested, fully charged battery before testing. I always throw this up in electrical classes because well-rested means it hasn't seen a charge for 24 hours and it's still at 12.6. If you're like me, I've never had a customer wait 24 hours before I could check.
Sorry, Mr. Smith, we can't test your battery till 24 hours.
So I'm not saying that the results you're getting are going to be so far out of whack it's going to affect the end results, but it's a nice little trivia question to ask. It said, yes, are you doing it right? And odds are you're not.
Yeah.
All right, test method number 3, most used. This is actually what G was talking about earlier. This is using a conductance style tester. Conductance style testers are nice because you do not have to have the battery fully charged in order to perform the test. This sends a very low AC voltage frequency through the battery, and it measures the amount of useful plate material left in the battery. That's how it works. And most OEMs and dealerships require this test and printout before they'll warranty a battery under factory warranty. So that's number 3 on the list. We had a comment come up there I caught that I want to catch too. Watch out for anti-seize compound on the connections. Absolutely. I guess some people would put that on the battery connection, but I wouldn't do that because again, it's not
I didn't hear
anti-seize compound.
Oh,
because it's not conductive. And that's certainly another cause for voltage drop in the circuit. Absolutely. And then number 4, I like this one. Using a scope to perform a battery charging system test. And I tell you, there's a couple of reasons why. First, there's a lot of information, as we'll show you in that one little capture. And number 2, what's nice about it is if you're new to scopes, you can get away from that excuse I hear so many guys say when they don't use their scope because they have to break it out and get it ready and plug the connections in. And I tell you this.
Leave it out.
Yeah, I mean, if you go into your shop, what do you do in the morning when you enter the shop? You turn the lights on, you turn the coffee pot on, turn your computers on. Why not set your scope up, turn that on, have that ready and go? And if you do this, I don't care which method that you use. Again, this goes back to taking care of your customers. You should perform this test on every car that comes in your bay. I don't care what it's in for. You should perform this test on every customer that comes in your bay. It doesn't take that long to do either the conductance test or the scope test. And either one gives you a nice little printout or a screen capture that you can share with your customer. And you may find some problems in there that your customer didn't know about. If you're on the other side of this, how would you like, especially folks like where these guys are up here in the north, where it gets kind of cold and it's getting to that time of year.
We still got more summer left. We're in the 90s today.
Well, you ain't very okay. Well, so next month it'll be cold. But anyway, when it starts to chill down, it takes a lot more for that battery to turn that engine over. Wouldn't your customer like to know, if you were the customer, that your battery is marginal? Yeah, it starts today, but then you're in a hurry to go to work or drop the kids off at school, and now you're stuck and it won't crank. So this is a very valuable
And this
service.
is a very easy test.
Yeah.
Looking at this as voltage goes down, so you got 2 leads connected to the battery post, positive and negative, right? That's the red line, and an amp clamp around the cable. And you can see amperage goes up as voltage goes down, and you can read that. And if we blow this up a little more, we could even kill 3 birds with one stone.
Oh, yeah.
The voltage, the amperage, and relative compression of the motor.
Absolutely. So what do you say we go over to the vehicle and we'll try these things out?
Yeah.
All right.
We'll stop babbling. Oh, one other thing I'd like to bring up, Pete.
Please.
You know, on a lot of the buttons that the power buttons rather than the key, some cars are very difficult to do a crank with the button. Okay. They're not all easy like the old days, turn the key and it cranks.
Yeah.
Sometimes you got to read a different procedure to put it into a crank mode.
Yeah, that's a good point. I guess we're going to find that out on the Mustang that we got to play with
I think
tonight.
so.
If that works for us. All right, so we're going to kind of mosey on over here to the car. And we're going to start first with our meter. And let's see if we can, we'll just leave right there. Because I got the meter in view there, right? All right, so we'll start with that. I'm going to go ahead and hook up the meter to the battery. In fact, we're going to cheat since we're already kind of plugged in. I'm just going to plug in to where I'm at. Because we have some of these Teslas that are set up ahead of time to, in the interest of time. All right, so then we're going to go ahead and we'll turn the meter on. And we'll give it a little backlight so you can see. All right, can we see that okay? All right, so here's your open circuit voltage reading, 12.6. Good or not? Can we move forward? And I'll wait a second. Yes, if we're good to go. No, if we're not. While you guys are doing that, I'm going to go ahead and select min max. And then we'll see if our cranking technique on this 2022 Ford works.
Couple of Ys.
Yeah, a couple of Ys. Okay, yes, we're good to go. We're above that 12.
Ready, Pete?
5. Yeah, go for it. All right, let it run for just about a minute or so. All right.
Good.
Shut it off.
I'll move the camera.
Oh, there you go. No, that's good now.
How's that?
That's good.
Okay. All right. So, and what you might have heard this underlying roary kind of a noise.
It's really loud.
This is a turbocharged engine, which a lot of the new 4-cylinders are. And if you're a diesel guy, you may have already kind of recognized that noise. But I'm willing to bet that one of the charge air pipes connecting the turbo to the intercooler and back again has got a problem, and that's that roar you're
Maybe
hearing.
something loose or broken or
Yeah.
whatever.
But it's a rental, so I don't care. I just give it back. Anyway, all right, so we have a meter in. Now we're going to go ahead and select the minimum, or well, we got maximum first. We got 14.3 as a max.
So that means
that's okay.
our alternator was doing something.
Yeah, so we had some charging going on. Then we'll hit the min. We got 10.5 on a conventional battery. So in this case, my down and dirty, nothing that stands out as a problem. That takes care of testing method number 1. Any questions on that while we gear up for the next one?
Okay.
I'm going to need that out yet. But I don't think I'm going to need the leads.
All right. So as Pete is changing this over.
Yeah, don't let any dead air there, buddy.
Oh, no. Dead air is killer. We could have Pierre sing a song for everyone.
That'll be a killer.
All right.
So now we're going to go to the, you do
I want to leave that.
the whatchamacallit, the unit.
I want to make sure I didn't leave that.
Yeah, just
I'm
leave
sorry,
that.
guys. Like I said, we just want to make sure we get everything covered there and don't miss out anything. All right. So what you said number 2 was the carbon pile load tester that we showed you the video of. So we're going to move on to number 3. And this is actually the Duralast tool. I don't know if they still do or not. Check with your AutoZone shop because they had some program for shops to get on their Duralast Gold battery line and everything. And if you signed up for that, then you could get one of these testers, which is kind of cool. So, like I said,
they have perfect clamps there. You can see Pete putting those clamps on. They are a perfect size clamp.
Yeah, that fits good. Good, it expands good.
Especially for today's vehicle.
All right. And this is, if you notice as we're going along, it gave us the output cable. That was okay. Now notice we already have a couple of tenths down on that battery just from those 2 starts. So we didn't give it really enough time to put it back in there again. Okay. So let's see what happens. We're going to hit enter. And then we have battery test, system test. And we're just going to focus on the battery for now. But this will allow you to go on and check the starter and charging system outputs. We'll hit battery test. And here's key. You've got to select the type of battery that you're testing. So we go here, we got flooded, we have an AGM flat plate, we have an AGM spiral design.
Spiral, that's it.
We have the gel battery, start stop. That would be the EFB. All right. So we've got a flooded cell battery here.
So go over that 1 second, Pete. That start stop is a what?
That would be the EFB.
EFB. So you may want to take note of that because notice it didn't come up, tell you it's an EFB. So start stop is EFB.
Okay, so then the next step, we select that. Now we have to select the rating. Now, a lot of different ratings out there. CCA is the one that we teach here in the States, but there's
well, that's at
DIN.
0.
Yeah.
CA is at 32 degrees.
Yeah. Then there's DIN, which
Then
is the
DIN
Euro.
is the Euro. Yep.
So there's different ones. In fact, we'll just kind of
Yep.
scroll through. We got
MGA.
MCA, CA, EM, Japanese standard.
Yeah. JIS.
The Euro
Japanese
standard.
Industrial Standard.
That's, I guess, the European Union, I think, for the IEC.
Yep.
And then we're going to select CCA. And now we have to select the amount, which you get off the label from the battery. In this case, it's 590. So we're going to click that down. Whoop. There we go. 590. Got it all set. Hit enter. Battery temperature. That's about right. We'll go with that.
Oh, thank God it's cooler in here than.
And now we'll test.
But under the hood, it's close enough.
Okay, so now it gives us the result. Good and pass. And then if we want, we can go ahead and print out the result. Here's the code for any warranty. Print result. Yes. Oh, I have the paper in there. Oh, well.
Well, Murphy's Law. It's
Murphy's
life.
Law.
Things happen.
All right.
We told you that before. Yeah, that doesn't want to print.
Okay. So anyway, that's just a really quick down and dirty. This is a lot more accurate than doing the first test, obviously.
And quicker.
And quicker. And like I said, it doesn't depend on the state of charge of the battery for us to be able to do that test. So I don't have to have a well-rested 24-hour waiting period or anything. Correct. I can go ahead and make the test.
And let's just show those cables one more time. These things are important, the smaller cables, because they could easily get on today's type of battery. Yep. Bigger cables can be a real pain.
Yeah, absolutely. All right, so we're going to set her off to the side. Hey, look, there's some of these Mountain Dew there. Hold on.
That's your MD.
There we go.
All right. So the next
I got that added pump in me.
That's it.
Okay. So now the next one we're going to do is on the scope. And let's just kind of put that up for a moment. You got the screen on there? Okay.
This is a Pico scope.
It's a Pico scope, and this is the new Pico 7 software. It is mated to an old Pico 6. I mean, old 3000 series Pico. So it shows you, if you have an older one, you can always update to newer software regardless and take advantage of some of the new features of that. But I just want to say off the bat, some basic settings when you're doing something like this. Now, I always go by the 20-20 rule. And in fact, let me pop in front of the camera real quick, and we'll go over that really, really quick. So when people are new to using scopes, and I'm going to ask for you guys who are watching, scope user, give me an S. Give me an S. Okay. If you're not a scope user, give me an N. Whatever.
What is this, the YMCA?
And if you're newbie, you've been playing around with it, give me a P. All right. So if you use it, you're good with it, S. If you don't, an N. If you're playing with it, give me a P. Okay, that's not it. Who is that? Those are YYYs. Alan,
CNS.
Ted.
Cool.
RTFI, guys. It's like S if you use it anyway. That's okay.
Close enough.
That. A lot of you guys are, so that's good. I'm glad to see that. Today, there's a lot of things in the vehicle you just can't test without a scope. And there are so many things you can test with the scope that are so much more accurate and efficient. We're not even going to go into that. But a lot of questions I get from new users is, where do you start setting up? Write this down because it's on your handout. I call it the 20-20 rule. You know, you have to set your voltage and your time divisions, correct? First 20, that's the 20-volt sweep. You want a total reading across the vertical line, the voltage scale of 20 volts. The second 20 is 20 milliseconds per division. So the typical scope, that would be 200 milliseconds or about a quarter of a second across the bottom of the screen. And this is about the time it takes for an engine to complete 2 full revolutions at idle, okay? Well, we're going to be doing some testings that aren't at idle. They're going to be cranking. And I want to see a lot more than that. So I'm going to keep the 20 volt, but I'm going to change that time to about 500 milliseconds per division. That's going to give me about 5 seconds across the screen when we're done.
10 times.
New scopes, they're so much easier to use. I'd rather put more time and zoom in than not have enough time and have to do the test again. So we're going to start with that, okay? So we'll go back to the scope, and we're just going to focus first on the battery. So you see we have the 20 volt setup, 500 milliseconds per division. The one thing we don't have in here yet is a trigger. So let's put that in. And we're just going to, I'm going to use the single trigger. I'll tell you why, because a lot of stuff I do is by myself. And this way I can set a level. The scope's going to start up and capturing the pattern, and it'll fill the screen and quit. And then I'll have it when I go back to it. Okay. So we're going to set it on single. Trigger, we already have on a rising slope, so that's fine. Channel A is the source. Pre-trigger, that's where on the screen it shows up. The time before that, it's going to record. I want it in the middle. I want to start here on the back side, so let's get rid of that. And we'll put in there 10%. And then the threshold, well, I'm measuring a 12-volt battery, right? So if I start cranking down on that battery, it certainly should. We saw on the DVOM test, it's going to drop to about 10.5. So let's say we're going to set this up to 11. Just for giggles, we'll say 11. And let me see, I want to change that to a
and then you're going to be putting
falling slope. So let me see if I can do that.
You're going to be putting the amp clamp on, Pete, as well?
Not yet. So, and where are you? Oh, duh. Sorry, guys. There we go. So I got the falling slope, which means that the scope is going to wait for 11 volts or less before it starts drawing a picture. All right, now I can hit run. You can see it's paused there. And if we go and crank it, Mr.
Crank it, sir.
And just like before, we're going to crank it and then let it run for a little bit.
Here we go.
All right, hold on. Hold on.
Good.
What? Hold on. One more time. Ready?
Here we go.
Go for it. That's what I'm looking for. All right, we got it. Boy, that turbo sounds terrible. Anyway, here's what we got on our finish on our screen now. Kind of noisy. But that's okay. We're going to go ahead first. We look here, and we can use our rulers to take some measurements. I'll tell you what, we're going to zoom in on a little bit so you can see it a little easier. And we're just going to come in and kind of take this whole section. Where are you at?
So it's going to blow that part right up.
Blow that
see
part
it
up
a little better.
See it better. And I want to point out, we'll point out a few things as we go. All right. So very first, what we're looking at here on the battery test, we can measure this down to where we started before we did anything with the key. And we get our OCV measurement. Okay. You probably see it's barely, it's about 12.8 is what we're measuring here. May not be totally down on where I need to be in there. Let's see, we're getting there. That's probably a little closer. So we're good there, right? We can continue, right? And now we're going to look at the lowest point on there. That's the loaded part, correct? Can you see that number? It reads 8.9 volts. 8.9 volts. So I'm going to get back in front of the camera here and got another question to ask. Same as before, guys. Good or bad? G or B? 8.9 volts. We just recorded at the low voltage. good or bad, G or B. If you're a scope guy, you should be like, oh, I know what that is. Come on, hit that key. And we'll wait for the delay. Good or bad, guys?
Now, someone's been using a scope for 45 years. Very cool.
All right. Some more, good or bad? So far, we got a mix.
Yeah, we got a mix there. Yep.
All right. All right. So here's the point I want to make here, guys. When you're using your DVOM, it's a digital tool. The scope is a digital tool. This isn't like the analog meters that we grew up with, or some of us grew up with many years ago. Some of you newer guys have been like, "What's an analog meter?" I've never seen. It's like the rotary telephones, right? Anyway, the reason it's called a digital device is that it takes in that input, whatever it's connected to measure, and it takes samples. So it's kind of going like this. And every time it looks, it records that and it puts up that average on the display. It's one of the things you have to keep in mind using your DVOM, because you may see a signal that's changing so fast, like a pulse width signal, and you're not reading the peak voltage. You're only reading the average of the low and the high. So, little tip for the wary. The scope, though, is like sampling up to millions of times per second. So it's getting a much, much better picture of what's going on inside that circuit. That's why I personally love my scope. What you're seeing here is that microsecond of time where we've completed the circuit, we've energized the starter motor, and we're getting the power through those windings, and the starter motor is going like, and it's got to start moving. First, its own mass, and then the mass of the engine is connected to. That's a lot of load.
That's a lot of load.
This is not the loaded voltage that we saw with our DVOM, because our DVOM can't see it that fast. You can with your scope. And here we call it inrush voltage. Inrush voltage, because it's that inrush of voltage and current in the starter motor to get it going. With me? So it's that microsecond of time on there. And this number, write it down on your scope, 8.5. 8.5 is the bare bones that I like to see it go. Anything lower than that, and it's failed the test. Okay? And when we do the current, we can actually demonstrate where you'd actually see the loaded voltage if we have time. All right.
Yeah.
So there we are there. So we'll go back to the scope. We got that one finished. And then note here how it's actually on a rise. Do you see that? Here through this section of the pattern, we're actually starting to turn the engine over now. And then all of a sudden we got the engine running. The alternator starts spinning. And it starts to return back in what it took out. So let's see if we can get just a peek of what we have on the screen.
Yeah, you got.
That's about right there, 13.7, 13.8.
Yeah.
And what I want you to look at here, guys, is that, again, we only have like 5 seconds of time on the screen. Look how quick we got up to that level. This should not take a lot of time. Not a lot of time. So you want to look at that. All right. Everybody go with that so far? Any questions?
No, we're looking good here.
Now, here's something else that we want to do. G mentioned it earlier. While I got my Zoomy out, I can actually go right here to the voltage line and look at it a little better. And I'll tell you what, I'm going to cheat a little bit. And
smooth that puppy out.
I'm just going to put a little filter on it right there real quick. And we could go into more in this, but you see how this pattern is kind of wavy. It's got little rounded humps along it. Did everybody see that? Now it's going up because that original slope was going up.
But if we were steady,
which we can look at later, or if we have the time. But what are you looking at here?
It's every time that piston's going up and down.
Well, not just that, but it's the AC ripple.
It was running here.
Yeah, this is the AC ripple that's being produced at the alternator. Now, that makes sense because the alternator produces AC. And there's a rectifier assembly made of diodes. I think there's 6 diodes typically in the pack that are responsible for pretty much kind of clipping off the peaks. If you ever saw an AC sine wave, it's kind of like this. And what we're doing with that rectifier is just kind of clipping off the peaks, and that's our DC voltage that we can send to the system. You need to take a look at this, especially if you're facing a drivability issue. Here's another question for you. I know I'm so into questions.
Full of questions, this guy.
Yeah. What if you know what is the maximum amount of AC ripple allowable? What is the maximum amount of AC ripple allowable?
Now remember, this is not your father's Oldsmobile.
Yeah, remember I said you might learn something that you didn't know before. So tell me,
That's it.
what do you guys think? What is the maximum amount?
Yeah.
Ooh, what is that
See
one?
that? That's just a comment.
Ah.
Time's
Maximum
flying
allowable.
by.
Right.
Hey, David. Haven't seen him in a while.
Right. Quarter of a volt. David says quarter of a volt. Anybody else? What's the maximum allowable? It's more.
0.5.
500,
500
0.5.
millivolts.
500 millivolt or half, 500 millivolts is the correct number that we're looking for in terms of what you've always been taught, right? No more than 500 millivolts peak base to peak is what we've always been taught. That's not true anymore. Some research has been done that shows because of the new alternator designs, you could have as much as a volt difference peak to base to peak and not have a problem with excess AC ripple. The key now is what's called the stator to rectification proportion. What you want to focus on when you're looking at your AC ripple pattern is it uniform? Is it a nice rounded series?
Right, because when the diode goes, it usually
depending on how it fails, they like either spike down or be missing. If it has abnormalities in the pattern, well, then you probably have a problem in terms of your AC side of the alternator. Okay. So there you go. There's just with the scope part.
That's another new one I learned today.
Yeah. Now what we could do is, since we're set up for it, is just a really, really quick, because we always like to look at the current side of things, don't we? So let's.
And all we're going to be doing is adding a high current probe. Okay. He's setting this up now on the second channel. And he's going to put this around. Make sure you got a good 9-volt battery in there, by the way.
Yeah. Let's see if we'll get through the installation.
Don't leave it on like I always do.
That's why I always put tape on mine.
Right.
And always have extra 9 volts around so you can see the clamp back there.
And Mr. Trulli would be so kind to crank her up.
Hang on. I'm just getting a picture of the
okay, sure.
The clampy back there. There we go.
Now, one thing too, when you zero these things, you should zero it where you're going to put it,
right,
and not up on your workbench. That's one of the nice things about that new 4425A, where the probes actually connect and are powered directly by the scope module. But you can do this with any scope, any clamp. All right. Wait a minute. Stand
Already?
by. Hold on.
Here we go.
Go for it. Go. All right. That's a nice pattern. That came out very nice. The voltage pattern cleaned up quite a bit, but I think we still have the filtering on that one. But that's okay. So you can see, I'm going to drop the current so we can see it a little better.
And that intersection of the blue going down right where the little yellow trigger is at, the blue going down, we see the current go up from 0, if you read the right side of the screen. And if the eyes are not mistaken me,
Hold on, buddy. I got you covered. 607 amps.
Is that 5 or
607 amps at the peak.
Okay. Yeah, because 5 something's the last thing I see on the side there. So you would normally not see this on a regular AVR, old amp volt tester, right? But reason why we're seeing such a high number on a little 4-banger is because we're able to capture this time a lot quicker than your tool can.
Just like with the voltage, it's that microsecond when the starter's trying to get everything moving. We got to go from nothing. It's the inertia of the whole thing. And just like we called it inrush voltage, this term is inrush current, right? Yeah. So inrush current. The 600 amps, not a concern. Perfectly fine, perfectly normal. Okay. So I wasn't going to ask that question. I saved you one. Yeah. But I'm gonna show you this as well.
But let's go back to that pattern and show them
Oh, wait,
once you blow it up.
Yeah, just wait a minute. Just hang on. He's gonna rush me here. He's hungry. He wants to go to dinner. Usually I'm waiting on him. He's waiting on me. So I want you to come here. I'm gonna, if you look carefully, you can see that I'm bringing the voltage cursor down to right across where we know that the engine's turning over, but has not yet started. That's where you see those little peaks.
11. What are you, 11.1 there?
About 11.1 there. Now, if I bring my measurement here kind of in line with that on the current pattern, okay, now we're measuring about 250 amps or so.
Yeah.
That is what you would call a more conventional starter current draw battery loaded voltage. Those are the numbers that you're used to seeing. And if you recall, we got like I think it was 10.5 or so when we did it with the voltmeter. So if we were to try to bring that up around the same, just kind of close, look where that intersection is. And this is what you have. I mean, I like to play with my scope, so forgive me.
No, don't tell us personal things, Pete, will you?
Okay, but then again, you can see we're looking. That's what your conventional training telling you about loaded battery voltage, starter draw. This is where you get those numbers from. Okay, and now to elude what my good friend was trying. Oh, sorry, one more thing there.
One more thing you got to do,
and I'll get to you. We'll get these out of the way. I want you to notice that here you can see on the current pattern. I'm going to bring it all the way down the bottom right. And that's showing, it says a negative number, okay, 30.25 amps. Notice that this negative number is not really negative in the sense that when you see the pattern orientation, that current draw, right, is going up. No, the probe is not aligned the way it should be to really truly portray on the scope what's going on. Current draw, which should be down. But we've all used to seeing it this way for so long. It's kind of the accepted norm for us. So when we're looking at that peak high, and now we're looking at that far right where it's settling down at that minus, that's really a plus number. And that is the amount of current that is being, the net amount of current that's being sent through the charging system. You want to see, again, this be replenished fairly quickly, letting us know that the battery's been recovered and it's on its way to being filled back up again. And you also want to look at the number on this, because if it gets excessively high, then that's a good indication that there's a sulfation in the battery. Something you may not pick up with the other testing methods. But what I would look for here is you have a customer that you know is having complaints about putting on a lot of alternators, or you've had a problem, you think the alternator is bad, you keep sending it back every 6 or 7 months. It may not be the alternator. If you have a sulfated battery, it's requiring that alternator to put out more than it wants to. Yes, it might be rated at 100, 150 amps. It's not designed to do that for any length of time. It's more designed for that small amperage load over that period of time. The other thing you're seeing in this capture is a result of the battery management strategy. When you're seeing such a high current initially, if we let it run a few more minutes, that should settle down and be probably under about 10 amps.
Yeah.
And that's net, guys. That's what we're taking out and what we're putting in. That's what's left over. That's the excess. That's the number you're interested in. Okay. And then one last thing.
His next magical act here.
Well, next, we're not going to do the whole cranking pattern, but we do want to point out that because of the scope, there's a lot more to see here than just the voltage. And I point out the little peaks that you see here. These are all the impact of the batteries, the engine's compression. As each piston gets up on compression, top dead center compression, that, of course, that makes the starter work harder. And that's a way that we can do a quick measure of the engine's mechanical health, which is one of the first things you should check using a drivability issue, by using this method. Now, what we would do there is disable the engine from starting, and we would fill the whole screen up with those little peaks and valleys, looking for them to be uniform. If the engine is cylinder is weak, then it's not going to take as much current to push it through, and you'll see that very quickly. And that's a lot less time consuming than to yank all the plugs out of a transverse V6, right? So
this has clear flood, right?
Try. I don't know if it does or not.
I didn't try that. It may.
Yeah. You want to give it a shot?
Yeah.
All right. Let's give it a shot. Let's see what happens. Hold on. Tell me when you're ready. Go for it.
Here we go.
Go. Yeah, buddy. Thank you. That's got it. See, now there you go, guys. not a drivability class, not an engine class, but there you go. It's called relative compression. And you can see that here they're all pretty uniform. If we need to know what cylinder is, we can tie off one of the coils to use as our index, and then use the firing order to identify any that are out of whack. But the other thing I think that I actually learned from my friend Mr. Trulia was that you don't need a current clamp to do that. Take a look at this. You see the same drops there in the voltage? Of course you do, because when the current goes up, voltage is being pulled down. So you're looking at the base of this because it's voltage drop, and then we're seeing the impact again on the cylinders. Oh, is that not good enough for you? I got all kinds of tricks up my sleeve. Let's try this.
This is just real quick as you're checking the battery, and it's a good excuse to pull your scope out. As Pete said, doesn't take a lot to do. You could give this printout to the customer. And as they come in down the road, maybe their battery or their engine or their alternator, something's bad. That's one way to make money, right?
You know, even if you don't want to print it, you could do a screen capture of that and send it to them in a text or whatever.
Exactly. And if you're not using a good management system, okay, something like AutoLeap, you know, you could send it through AutoLeap, put it in there, and text it, email it, and put it in the customer's file.
Okay, now we've done all the manipulation here. All I simply did was use the invert function on the tool to turn that voltage pattern upside down. Now you see it's darn near a mirror image of the current pattern.
Right, especially if you blew it up.
Yeah, especially if we blew it up, you'd really see that correlation. And again, that just shows you that you don't need a fancy scope. There's some really economical single channel scopes out there that will allow you to perform these tests and you know, save yourself some time and speed up your diagnosis. Okay, all right. So we're not done yet, but we are done with that. So we'll turn that part off. And now we're going to move on to the starting system. Okay. We're going to go dive right back into the car in just a moment. We've talked about and shown you can use this technique to check the starter. If you zoom in that pattern just before the peak, you would actually be able to see where the solenoid is closed. You could get an idea of how much current is being drawn across those, what the condition is. A lot of information you can find in that one capture. You can use your conductance tester to perform that starting charging system test. So, you know, we're not going to focus on that so much. What I do want to show you, and what we both agree would be really good to show you, is something that's commonly overlooked, and that's checking the voltage drop in these critical circuits. So let's start by looking at the starter motor first. Now, there's a couple of ways that we can do that. I'm going to set it up on the voltage scale. And I like an idea that Mr. Trulia shared with me. He said, you know what, set it on the millivolt scale. Why? Because typically these will only measure, what, about 500 or so millivolts.
600 is on this.
600 on the fluke.
Max.
So if I see any reading on there beyond that, we got a problem, right?
OL means you got money coming into your shop.
Yeah. All right, so we've got the leads already pre-hooked up. My red lead here is connected to the positive battery cable down at the starter. So I'm going to put that in the black. You say, why black, Pete? Because I'm going to reference it to the positive cable on the battery. So we can just check that side of the circuit first. All right?
And these wires, we pre-wired it.
Yeah, pre-wired it earlier.
And this happens to be an easier card to do. Lucky on this rental.
Yeah. And then we'll just hit the min-max, and we'll go ahead and just crank it. Do the clear flood if you want for just a few seconds. And... Whoop, hold on. Oh.
What happened? Camera moved?
Camera moved.
Yeah.
Oh. Sorry about that.
No problem. Go ahead.
All right. Clear flood in it. Here we go.
Go ahead. All right. Hold on. All right. So I missed. Hold on. Hold on. All right. So I must have made a mistake here in which lead I picked. So we'll verify that. I don't want to make that mistake.
So again, when it's live, stuff happens.
That's it. That's it. Right. So I am in. Oh, yeah.
And
Let's
you know,
try
when you're
that
doing
again.
all these tests, you should have all your accessories off.
Uh,
So he's
okay,
double
yeah,
checking the
why.
wires.
That's why. No, hold on.
It's okay.
Gotta follow my voice
Again,
around.
you know, when things happen, it's like being in the real shop, right? It happens every day.
Absolutely. So that was my error. I had this set up on the ground side. So we'll move that puppy. In the meantime,
So
I'll
just
turn that
moving a
off.
lead from the ground side to the positive side, so we
So I
can
want-
measure.
Basically, what we're trying to do is make sure we're on the positive side at the battery, positive side at the load.
So at the
and I
load,
think
it's going to be the positive terminal where
There.
the big
There.
wire comes down, cable wire comes down.
Oh, wait a minute. Let's see. That's
So it's just playing switch the wire game.
just playing a switch the wire game.
Any questions in the meantime?
No.
Right.
You know, I don't know if we're going to have time to do the parasitic stuff, but there was a comment at the very beginning about an aftermarket dongle in the DLC connector creating a draw. So maybe Jerry, you want to talk about
Okay,
Oh,
so
yeah, good point.
parasitic draw, a dongle in the ALDL.
it?
Never,
It was in the 16-pin socket.
Yeah,
It was
the
a-
16-pin OBD2
dongle,
connector.
you know,
It's
want-
never a
get-
good idea to have anything in there when the vehicle is driving. Yes, insurance companies would like you to put it in there. A lot of them are getting away from that because of liability. Okay. The OBD2 connector was never made to constantly have something in it to take data from. As you know, if you plug your scan tool in and you go in to the brake system, what happens to your ABS? It's not functional. So there's some lawsuits going on from different companies that their dongle was in the diagnostic link connector and it caused an issue, whether it be a stall out or a braking problem. So that can cause a parasitic draw as well. Not a good idea to do. Other things for parasitic draw, well, a good tool to have is a thermal imager. And when we do parasitic draw here, you may have read my articles in Motor Age magazine. We always leave the vehicle inside. That way there's not sun that is going to make things look bright, a bright color that would indicate a draw. And there's no heat on the car. So even in the winter, it would all be evenly heated. You look for something that is bright. And again, we have many, many videos up both on Motor Age and TST seminars on our YouTube channel, besides the TST seminar website. So thermal imaging is a biggie, and having a good amp clamp. Now, a lot of people try to use the little PDI amp clamps that you can get in a e-scope or in a Pico scope kit. Those are not good enough because they don't have big enough jaw to fit around the cable. I like an I-30S, I like an I-30, S like in Sam amp clamp. It will set you back probably 600. Nowadays, I think it just went up to over $700. But we've been using it for years, and it is super accurate down to 15 milliamps.
Okay.
And now Peter's ready, so I could stop.
I believe
yakking
so.
About
So,
parasitic
and I
draw.
want to go back and show the guys because it was my mistake. So many leads under here. I got the wrong place. All I'm doing here is I'm putting positive meter lead down at the source, right at the pin where the positive battery cable connects to the starter, and then the other is connected to the positive side of the battery. So I'm checking the entire circuit path between the B plus at the starter all the way back to the battery where it's originating. So I'm checking the entire positive side of the circuit. Right now we're reading about half a millivolt. And let's see what happens when we clear flood.
Okay, here we go.
All right. You made me miss it. No, we got it. Never mind. All right, so there you go. Again, we're in millivolts. I'm reading 145 millivolts, which is nothing in terms of voltage drop. But what I like about it on this side of this, by doing one side of the circuit at a time and using the method that Mr. Trulio showed me, by sitting on millivolts, if it was over half an amp or so, then it would go OL, which I can term as out of luck. And that means I know I have a problem on that side of the circuit. So that takes care of the power side, but you know where most of the problem lies? It's on the ground side. So all I'm going to do is I'm going to switch the leads around a bit.
The forgotten side, and you meant to say voltage, not amperage.
And then we're going to, now the reason you're seeing the battery voltage is because I'm on the ground side on one end, on the positive side on the other end. So I got to move my other meter lead to the ground side of the battery so I can just check the ground side of the system. And while I got that real quick, you notice here how the end meter reading is nice and stable. If I were to take one out, you see it bouncing around a little bit. Looks pretty good about holding its own. There others are much more prone to that. If you see your meter reading bouncing around when you're doing this test, or certainly when you're trying to do a parasitic draw across a fuse, that's telling you your leads are not connected. It's called ghost voltage. It should give you a nice stable reading like you see here. We'll go ahead and put it back on millivolts. Ready to check the ground side. Crank it when you're ready.
Here we go.
Check it. All right, got it. And there you go. In that case, 110 millivolts. Nothing wrong with either side of the starter circuit. All right.
You'd start to worry if you had over 200 millivolts, but it's always a good idea to check stuff out, right?
Yeah, oh, absolutely. And I'm going to say this too, guys. Sorry, I'm going to say this too, guys. When you're doing this any kind of a voltage drop test, and I'm sure G will attest to this as well. In my experience, anyway, if there's a problem, you're not going to quibble over a few tenths. It's going to stand up and bite you in the butt. You know, it's going to be there where you can easily see it. So we want to make sure we do that. Now, here's a question for you. A car came in on a hook, no start. You quickly determine starter motor is shot. So you do whatever troubleshooting you did to make that determination. You're ready to sell the customer a starter motor. Are you done with your diagnostics? What about the cables? Well, we just tested them, but we had a good starter motor to do that with. How are you going to do that if you don't have the good starter motor to do it? Take a watch. Ready? Let's see if you can hear this from better. Now, here's the idea behind the test. We're going to use this to load those cables down rather than the starter, because again, the starter that's on the vehicle isn't working. Is this something you can build to your customer? Can you crank up the volume on the TV?
Probably could. You're doing a check on the cables. That's a performance test. That's something you should be able to bill for. And all we're going to do is we're going to hook this up, like I said, in place of the starter, and then we're going to read voltage drop across the load. This, and that's what that little digital meter is going to tell me. Now, that goes back to basic electrical fundamentals, doesn't it? A good circuit and a good series circuit, all of the available voltage from the battery will drop across the load. Maybe a few tenths left over, and that's what we're looking for. So to perform this test, we're going to need this, and we're going to need a voltmeter connected to the battery at the top. Let's go and get it set up step by step, and we'll show you how this technically works. Okay, now in preparation for this test, again, this is a no crank, no start tow-in. I've already identified that the starter motor has failed on this vehicle, but I need to check those cables. So I disconnect the power cable down at the starter. Of course, disconnected the negative cable at the battery first to make sure I don't arc anything in the process. So I've got the bottom already set up. The cable going to the starter motor is disconnected. Now I'm going to set my voltmeter up top with the battery here, reconnect it. So we're just going to start up my
we don't have to do it now. Somebody's complaining. So
let's put a little backlight on there so you can see it.
Maybe in that video.
And the very first thing I want to read is open circuit voltage. Is my battery healthy enough for me to test? If I read anything, personally, 12.4 is an absolute bottom line number for me. If I see anything at 12.4 or lower, then I need to charge the battery and then verify that the battery is indeed good before I proceed. But we got a good battery here, so we're going to go ahead and proceed with the test. The next thing I'm going to do is I'm going to set my meter to record min-max. Specifically, I want it to be able to tell me in a few minutes what the minimum voltage it sees at the battery. So I'm just going to go ahead and set that up. And now I'm ready to go up underneath the vehicle. Okay, just to recap what we've done to prep so far. Again, no crank, no start, towed in vehicle, have verified that the starter is no good. Now we just need to make sure that the path between the starter and the battery is okay. Since this is going to be a very high load component, a lot of amperage flowing through it, just hooking up a headlight bulb across it's not enough. We need to put some serious load on it. That's what this tool does. This tool will apply about 100, 130 amps through those cables. So we're not going to use this on every load test we do, just here for this starter motor, okay? Now, what do we do to prep? Well, I couldn't access the cable when it was connected to the starter without accidentally arcing against ground. Believe me, I tried and found out that wasn't going to work. So I went upstairs, I took the negative battery cable loose, came back downstairs to remove the cable, positive cable from the starter motor, and then went back upstairs to take the negative cable and put it back on the battery. And as you saw, I now have my multimeter set on min record mode to monitor the battery voltage upstairs. We're just going to replace the starter as a load with this tool. Now, this tool is normally used to check the battery and charging system and would connect directly to the battery. By coming down here and going through the cables and the ground, well, now I'm checking the entire path to the starter motor, aren't I? I'm including the cables. So I should be able to detect any voltage drop through those cables or any additional loss by comparing the two readings. That's what we're going for here. So all we're going to do is we're going to connect the positive end to the starter cable, and then we're going to connect to the starter ground. This way I check going through the starter case to the block, and then of course through the cable back to the battery. And I know you can't read this. Right now it's reading 1278. That's within a few tenths. Of course, the battery's dropping a little bit upstairs. What I'm going to do here, though, the main thing I want to catch is what happens under load. So I'm going to apply the trigger. I only need to apply it for a few seconds and then read the voltage. I'm not trying to do a battery load test. I'm trying to stress the cables to see if there's any weaknesses there. So here we go. 1, 2, 3, 11, 10 is what I just read on the digital output. Now, as I mentioned, this tool has an analog version. That's going to be a little tougher to do this test with, but if you already have one, you can certainly use it to do this job. All right, so we'll go ahead and remove this very carefully. And then we'll go back upstairs and see what our minimum at the battery is. Okay, so now I'm back upstairs. What I want to know now is what did my voltmeter in min-max mode record as the minimum voltage at the battery? All right, what we got a reading here is 11.46 volts. The 11.46 volts now becomes my standard, if you will. That's the source voltage that I'm going to use when assessing how much voltage drop occurred over the circuit path and through the load. Now, it just so happens that when I applied the load through that handheld tester, I could also read the voltage that was getting to the tester. What do we read there? 11.1. The two subtracted from each other leaves 0.36. That's the amount of voltage drop that I have in both the ground and power sides of the circuit. Is that an acceptable amount? You bet it is. I don't have to go any further. But what if I had seen a larger number, something approaching a volt or more? Now I would have to isolate whether it's in the power cable or it's a ground-related concern. That's easy enough. We're just going to move the tester between the two and perform the test again.
All right. We're not quite done yet, so just forget the question straight. We'll get that one more time. For everybody understand that, all we're doing is we're using the load tester, and Jerry's got a few in the shop here. And you probably have yours too. It's just a handheld load tester that you can use to load the cables down and complete your diagnosis. It's sure to be putting that new starter on and finding out that it's not working right, or missing excessive drop in the cables that will lead to the early demise of that starter. And of course, we all blame the starter when that happens.
So something old is still can be used. I mean, I wouldn't recommend using these on a battery.
No.
Okay, unless you want to heat a Pop-Tart on, right? Or heat your hands up. That's what these things will do.
Yeah.
But good to load the cable.
Yeah, absolutely. And a couple of questions came up. One of you guys asked about where we put the leads when we did the test that we showed you with the voltmeter. Voltage drop is a learned skill. And when you are comfortable with it, what we're doing here is we're checking one side of the circuit at a time. So we have 1 meter lead on the battery, reference to the battery. Whether if it's the ground side, it's going to be in the ground side post. If it's on the positive side, it'll be on the positive side post. And then the other meter lead goes to its partner on that side of the circuit, whether it be the positive side of the load or the ground side of the load. In this case, with the starter motor, the B+ cable or the casing, which answers your question, we're on the starter case because that's the start of the ground path and the starter back to the battery. You'd be amazed at how many issues you got with voltage drop between the case and the block because it was installed improperly torqued, corrosion, you name it, didn't clean the surfaces off. A lot of those things can impact that. And if you have voltage drop, what that means, guys, is that there's a thief in the mix stealing away from the voltage available to the primary component, in this case, the starter motor. So if it's not getting everything it needs to work, is it going to work right? Of course not. So that's why we want to make sure we make that check.
Excellent explanation.
All right.
Excellent.
Any other questions that we're at so far? We have one more thing I want to do before we call it a night, okay? All good and dandy? All right. So the next component we want to verify is the alternator. And I'll back up a step. On the starter, on the solenoid side, the key on the switch voltage to the solenoid, you can check the voltage drop in a similar manner. Your solenoid just becomes the load. Same when we're doing the alternator, you have the field and, of course, the alternator assembly itself. Let's take a look at how to do both the alternator positive and ground sides at the same time. So let me set that up while G
Yep.
keeps you entertained.
So basically on the alternator here, we're switching some of the wires. Okay. And we, as you can see down here, okay, there are wires where you see my hand waving. Hey, how's it going? Okay. And Pete is getting this hooked up. It's going to go to the battery. And now he's connected in over here.
Now, what we're connecting into here is this is attached to the B+ terminal on the back of the alternator. That's our positive side of the circuit. Okay, so that's where this one's going.
Okay, so that is the
one more to do.
feed side. So now he's figuring out where did I put the rest of the wires. And as he's taking that out, the one's going to go to the negative side of the battery. And you can see he's getting ready to put the connectors there. It's positive and negative at the battery.
And we have one more we want to do.
All right, so now he's piggybacking on that.
Still on the ground, but
And now he
now
has to figure, where's the ground? Where did I put it?
this is now the one we're hooking up here is actually the alternator case. Again, just like we did the starter motor, that's where that ground path starts.
And always make sure your wires and stuff are clear of any moving parts.
Yeah, we're okay.
We are okay.
And I want to make sure that I have the right channels in the right place. So I'll tell you what, just like you would any other time. Whoop, I didn't want to do that.
All right, so we're getting the scope ready.
Back up again.
By accident, he hit the exit button, but that's okay.
So anyway, I've got A, B, and D are actually hooked up. So we're going to put both of these in, and we're going to use the standards I said before. We're going to have the 20 volt for the voltage, part of the 20/20 rule. And I tell you what, because we want to trace this out a little bit, I'm going to bump up the time.
Bump up the time there. Good idea.
Bump up the time. Bump up the volume. And now you can see they're all overlapped here, so I want to kind of spread them out so we can see them better. Here. Now, someone commented also about the leads, and absolutely right. You need a quality shielded set of leads if you're going to do scope work to help protect your measurements from all that electrical interference under the hood. And are you on?
You muted yourself.
Did I mute myself?
Now you're on.
Now I'm on.
Thank you
I'm
guys.
just having
for
all kinds
letting
of
us
issues
know.
there, aren't I?
He must have been scratching his you know what and hit the mute button.
All right. So you can see that we have. Well, I'll tell you what. Let's start it up and let it
Okay.
run, and we'll see what
You
we
want
got.
you want me to start it?
Yeah.
All right. Let's hear this noisy Mustang again.
All right. So I've got some noise there on the battery. I'm going to put a filter on that just to be on the safe side. What you're looking at here, and we'll freeze it there.
Let me know when you want me to kill it.
Yeah, hold on just 1 second. All right, you can kill it.
Noisy baby.
Now, just like before, I have the case ground checking the positive side of the circuit. That's the B plus between the alternator and positive side of the battery. And then we have the ground side also casing on the alternator and negative side of the battery. And then the blue, that's voltage at the battery itself. So what you're looking at here, we have very little offset on voltage drop on either of the other two channels. So that's telling me you're pretty good. And the other is just battery voltage like we looked at earlier. We can open that up and you can start to see some of that. That's hash. Okay, that's not a problem. I just want to show that to you because we have some noise in there. Could be a connection or something. We can check that or worry with it, but I don't want to waste your time with it. But we can also use that to check the AC ripple. The reason I wanted to show this on the scope and kind of bring us down to the end is this. You could check it with your DVOM, but remember I said a long time ago about not being able to get a fast sample rate with your DVOM. What if you had a case, customer comes in, lights are flickering, dash lights are flickering, warning lamps are kind of illuminated, but they're really dim. I saw this a lot on PT Cruisers back in the day. All caused by what he said earlier, problems in the negative ground strap where it split off and attached to the chassis. So you have that voltage drop in the ground side, that affects the strength of the field. That creates a lower field, that creates a charging output problem. If you're connected, like you're seeing us do here with your voltmeter, you're going to see the average. You may miss it, but you're not going to miss that with your scope. I've got some great captures. I wish I should have included those. But you're going to be able to see that variation, that variance very, very clearly on the scope. So that's just another feature for that. All right. So that kind of brings us down to the end here to our questions.
You lost your clicker.
I lost my clicker.
Well, then we'll...
I'm a clicker loser. All right. Anyway, we want to make sure that we thank our friends at Duralast for making this possible.
Yes,
for
thank
making
you,
it possible
Duralast.
for you guys. Hey, do us a favor. Let the folks that you go to the AutoZone store, they're going to kind of look at you and go like, what? But let your store know. Hey, you guys did this for us. We appreciate it. Check out their line of equipment. And then we've got the next one up here. Just to let you know, if you haven't heard it already, if you want to see myself and Mr. Truly in person, we're going to be at the Embassy Suites in Rosemont, Illinois. That's just outside of Chicago. That's
along with our two friends,
Yeah.
Scott Brown and Brandon Steckler.
Yeah, so this is a four-for all day long.
Hey, watch it. Family show. Okay.
It's October 15th, guys.
Yes,
you can
come
register.
out and see us. Come out and meet us.
It's www.thewordaccelerate-conference.com. And I think we're asking, it's under $200 is what the rate is to come out and see this. But listen what's going to happen. You're going to get fed in the morning. You're going to have three talented presenters and me presenting classes for you that day. Let me tell you what, seeing this guy, seeing Scott, seeing Brandon just by themselves is worth the price of admission. We're going to feed you lunch. And then at the end of the day, we're going to have a meet and greet, maybe some pies and some cold ones and get a chance to hang out and talk a little bit after the conference is over. And we're going to have some sponsors there who are going to be exhibiting, give you a chance to interact in between sessions with these different companies, find out what's new, what's exciting. got some issues you want to talk to them about, whatever the case might be, it's going to be an excellent opportunity for you to do that as well.
Yeah, so come out and see us. You'll get to see all 4 instructors. Today, someone called me up, actually Kenny Zanders. He had someone interested in coming to this event. And I was told originally you're going to see all 4 of us. Are they all going to be 4-hour classes? No, but they'll be long enough with good information that you will know it's worth coming out to see all of us.
All right. And the next up on the list there.
Then I got to give myself a plug here.
Oh,
so if you want to come to an electronics class, October 3rd, 4th, and 5th, it's a 3-day hands-on class. We go out from 8 in the morning to 4:30. Or perhaps you want to come to the EV hybrid class or hybrid EV class. This one you better rest up for, because we start early, 7 in the morning, and sometimes we don't end to 10:30, 11 o'clock at night on Friday and Saturday. Sunday, we always get everyone out of here by 4. Electric vehicles are coming. Important thing to do. Been doing it for years, so we want to thank you guys for coming out.
Yep.
And
I don't. Oh,
Let's leave that up.
can you back up to number 36 there for a minute? I think it's where I missed.
This one right here.
Yeah.
Okay.
Yeah. And it'll start here in a minute.
Okay.
Hey guys, we want to put this up there because we want to make sure we do acknowledge our sponsor for making this happen.
And press and play.
Oh, why not?
And when it's done, you need to tell them the handout.
Oh, maybe.
Let me try it this way.
Try it right there, yeah. Must have had a problem. Well, yeah, it's going. Give it a few seconds. Yeah, I know there was some blank here. Bad edit. Bad edit. Maybe I had a really bad edit. Oh, there we go. Okay. 20 seconds in. We're good.
Starter or alternator is indeed.
Hang
Oh,
on.
what'd you do?
I was trying to play it here. Well, I guess I can't make it bigger.
You got it. Just put it back where it was.
We're playing it from
Always got to be playing with things, don't you?
That's it.
Try there. That should be pretty darn close.
And
There
if
you go.
it's verified that the starter or alternator is indeed bad, make sure that you replace it with a quality, dependable component like those offered by Duralast. Duralast alternators and starters are triple tested and remanufactured by Tier 1 manufacturers, not just rebuilt. That means all components, subassembly and end units are tested and replaced with new wear components. And if you're looking to offer your customer a completely new unit, the Duralast Gold line offers 100% new starters and alternators. Both Duralast lines are engineered and tested to meet or exceed OE specifications for form, fit, and function, including amperage or torque output. And if a known defect is present in the OE design, Duralast engineers address that defect so you and your customer won't have to. They also come back by a full nationwide warranty, including roadside assistance.
Okay, we can go back to the last shot. We got that done.
So let's thank our
Yeah, so I'll tell you what.
Duralast people once again.
Yeah, and we had a question about the handout. Can you back that up to up the top there so they can get that link? Right there. So if those of you asked about the handout, it's a copy of the presentation, bit.ly/battery webinar. You can download it from there. And let's see, I think there were a few other comments we want to make sure we address. The RAM 50 V8, you're asking about the screen and the die bench. I'm not really sure which one you're talking about. The little rolling cart we have in the background is just a simple monitor on the rolling cart. But if you do some Googling or get on some of the Facebook automotive technician groups, a lot of guys have built their own, with a rolling cart and a TV monitor mount, and then just made that their diode cart. It's a really good idea. You can keep it all in place. The guys here, they've got the snap-on setup, which is also very, very nice.
But we do use that cart over there,
Yes.
and another one. But on Facebook, I know there's definitely a couple of groups. I think, I don't know if it's Mario or whoever, but quite a few, or Markham does one. He has a real nice cart where he has a TV in the background.
Yeah.
So check them out. You could buy whatever brand cart you would like and put a nice TV at probably a 32-inch or more monitor, and bingo, you're ready to rock and roll.
Yeah.
Especially if you buy touchscreen.
Some of these guys have really gotten, really inventive in how they set those up. So, your imagination is your only holdback. Hey, wrapping it up, guys, thanks so much for coming out and hanging out with us tonight.
Thank you.
We know that we had in the first half, we had a lot of yeses for you knew something new. So I'm going to challenge you with one more question, and then we'll call it a day.
He's a Q man.
We're in the second half, and we did a lot of the on-card testing. If you pick something up in the second half you didn't know before, hit me with a why, and you know what? Let us know if you really liked. Some of you already said so. Thank you for those comments. So if you did, we met our promise, and you walked away with at least one thing new. Put a why, and then we'll wrap it up for the night.
One question here.
Yes.
One question.
At the end, wanted to know if the Big Jaw amp clamp would work with the Zeus.
Yes.
Yes. Short version.
Any amp clamp will work with it. It may not have the preset settings inside there, but you could always do every 100 millivolts equals 1 amp.
And to Snap-on's benefit, I mean, they make their own design for their scope that does have that in their drop-down menu. So either way you go, but you're not limited to that. So
right, you can use it. We use it on the Zeus all the time. So once again, I want to thank you. If you think this was good and was worth your while because he said a different letter, give us the letter G, like in me. Give us the letter G. If you thought it was good, if you thought it was bad and you got nothing out of it, we wasted your time, which we hope we did not. Give us the letter B. B if it stunk, it was bad, you don't like us, the letter B. G if it was good.
They're nailing
Thank you so much. We really do appreciate.
Hey, I had fun tonight.
Saturday night.
It was a good night.
Hey, I made you do all the talking, which is really nice.
That's kind of like strange.
Yes, saved my voice, which is hurting around.
Okay. All right. With that said, again, one more thanks to the folks at Duralast making the night happen.
Yes, thank you, Duralast.
We will not be here in September, but we will be in October. So stay online for the date and time for that. Of course, it'll be on a Saturday at 6, just like now. And you'll find out when either by email or notification or however you learned about this one. You'll find about that one. And don't forget, take all the advantage of the learning platform that you're on now under Motor H. There's a ton of stuff there for you to take advantage of. And with that, I'm going to say good night.
Good night.
Good night. Good night and God bless.
Thank you.